Yes, good morning, ma'am. Shall start? I'll start.
Sure. You can hear me loud and clear, right? Hello.
Good morning to all the respected dignitaries, faculty members, and participants. We welcome you all for today's session on domain applications of quantum assisted federated learning. It's my great honor and privilege to introduce our esteemed resource person for today's session, Ms. Aditi Lal. She is currently working as quantum computing developer at BQP Bangalore. Ms. Aditi Lal is an applied mathematics researcher working at a intersection of quantum computing and physics driven modeling with a strong emphasis on practical hardware oriented implementations. She has worked with Weiser as a research fellow in collaboration with Europe's leading energy organization. Her recent work at BQP spans quantum Monte Carlo inspired methods, orbital mechanics modeling in the ECI frame, and the development of physics informed neural networks for dynamic systems, where she focused on learning state evolution for satellite directly from position velocity representations. She is actively engaged in executing and optimizing quantum algorithms on real hardware and simulators, including variational approaches. Her research combines rigorous mathematical formulation with implementation level detail, aiming to bridge theoretical quantum methods with deployable real world solutions in scientific computing optimization. We are truly honored to have such a passionate researcher and innovator with us today. I am confident that her session will provide valuable insights into the emerging applications of quantum assisted federated learning and inspire all of us to explore the future of intelligent and secure computing systems. On behalf of everyone present here, I extend a warm and heartfelt welcome to Ms. Aditi Lal, ma'am. Now I request Ms. Aditi Lal to kindly take over the session and share her valuable insights. Over to you, ma'am.
Thank you so much, ma'am, for the warm
Ma'am, please,
introduction.
ma'am, you may proceed.
Can you hear me? Hello. Hello. Hello.
Ma'am,
Hello. 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 Can you hear me? Hello.
ma'am, Aditi Lal, ma'am.
Hello. 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 Can you hear me? Hello.
Not able to hear.
Hello. Hello. Can you hear me?
Yes, ma'am, we can hear you.
Okay. 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 Thank you for the warm introduction. We'll start. I'll share my screen. Let me know if you guys can see it. Uh, is my screen visible to everyone?
Yes, ma'am, it's visible, ma'am.
Okay. Um, to remove this. Okay. So today's talk, as you all already know, we would be discussing about domain applications of quantum assisted federated learning, and this is a faculty development program. And as already introduced, I am Aditi Lal from BQP, and I work as a quantum computing developer and a researcher. Okay, yeah, this as discussed, the program would be for 90 minutes, and I would be focusing on practical domain applications of cutting edge quantum machine learning. Now, the session flow, as I have kept on my slides, is something like this. We'll start with introduction to artificial intelligence, federated learning, and something about quantum computing, because we want to know how these topics also flow with the help of quantum computing, and what advantages does this have over various fields and use cases. Then we'll see some fundamentals about federated learning, what that is, and the limitations of classical federated learning. Why did the need of moving to quantum federated learning or quantum machine learning arise in the first place? Then once we know why did the need arise, we'll move to introducing quantum machine learning, and then we'll see, like, as we know, quantum federated learning is a part of a bigger umbrella of quantum machine learning. So we will later see quantum assisted federated learning architecture, and then we'll see some domain applications where all this can be used, like healthcare, space, energy, climate. We'll see all of that, and then some challenges and research directions we'll have, and then a small case study of how things go around with this architecture for a particular, I think I've taken an energy sector case. So we'll do that, and I have some Q&As for everyone now. Okay, let's start the introduction. Why are we even talking about this? Because see, in the real world, the data explosion is an actual challenge. Data is generated every second. I am delivering this session, you are recording it, that is data. Me and you talk about anything, that is data. Transcribing this meeting is data. Data in text form, data in video, data in audio, everything data, every second data is being presented. In healthcare systems, every time you go to a hospital, you get yourself checked, somebody else get themselves checked, that is data. Industrial sensors, uh, anything in your phone these days, you have sensor based robots that can clean your houses, that's a very big example. But here and there, sensors everywhere. In your colleges, you have these sensors, automatic light operations on the walls, on your rooftops, that is sensor. Every time that's blinking, that means it is recording on an average how many people pass through that corridor in a minute or in an hour, whatever, or however you want to record that data. That is data. It does not feel like it is data, but it is data. Every time you do anything, that is data. It does not feel like it, but it is. Satellites and smart grids, as it was also said in my introduction, I work on these. I work on propagating where the satellite would be in a few seconds or a few hours. That is data. Any satellite that is going around in on around the earth is data. What is its orbit, what is its speed, what is its velocity. We use, for people like us who work on physics informed learnings or machine learning models, we use that data because we need state vectors to propagate where the satellite would be. Smart grids, these days energy is a real problem. Like, for example, let's take this example. In summers, there are places where it is very hot, and then there are places where it is not as hot. In the same city only, where there would be trees, there would be lesser heat. In an industrial area of the same city, there it would be very hot, very hot. Now, distributing energy to the right houses at the right time is also a big problem in the energy sector. So developing smarter grids, trying to solve these problems, these topology problems, however you see it, you see it as a graph theory problem, you see it as a topology problem, however you see it, that is another data that needs to be taken into consideration to solve some problem. Then of course, financial systems, every time you are sending money somewhere, every time you are doing a bank transaction, or every time you are buying something online or offline, that is data. It is being recorded everywhere. That's why only whenever you see something like UPI has grown from XYZ percentage to ABC percentage over here, because all of your transaction is being recorded. That is why the government has data, like saying things like, today we had, say, 90 crore transactions. So that means your transaction was also taken into consideration. Everything is being recorded. So that is data. Autonomous system, everywhere, everything that is done is data. So if I just consider about traditional artificial intelligence, that is just centralized learning. All data coming to a single server and then training. So it is very difficult. Say You have a big robot, you keep feeding that robot every data that you can think of, everything, healthcare, energy, industrial, finance, everything. It does not have a bifurcation, it is just rot learning all the data. So that is a big problem. Data explosion is a challenge. So, centralized AI critical issues, what are the limitations from this? There can be some privacy leakage. Uh, if not trained well, if just dump data in a place, there can be some private information that can be leaked. Because sometimes what happens is, say you ran a code on some quantum computing hardware, and then you have your own token. You're not aware, you just want to get your code corrected for some reason why it is not learning or running. You copy paste that code in chat gpt without realizing that code also has your api token, which cannot be released to the public, which cannot be fed to the ai, which is very dangerous. So that is a real problem if we just keep feeding in data without realizing what we are feeding in, without any bifurcation. Then massive communication overhead. Of course, if you keep, think about one person. If somebody say you are sad and you have one person to go to and you cry about the problems in your life, now if that one person is hearing about everybody's problem, think how difficult it would be for that one person to take so much into consideration, and that would start hampering his or her own life. That's a real problem. Regulatory challenges. Now every domain comes with its own moral challenges, its own regulatory challenges. Some domain need information to be fed at night 24 into 7. On the other hand, you're in college, your sense, nobody is inside the college. The sensor on your roof will not work because nobody is inside the college, and usually that is how it is supposed to be. So your system knows that, okay, in education domain, so and so sensor information would not be fed at night time at least. But on the other hand, in healthcare system, every second information is being fed. So AI would not know when to be active, when not to be active, when to respond promptly. That has to be regulated. So every domain comes with its own challenges of regulation. And then, of course, security vulnerabilities in different sectors. Some information cannot be compromised upon, while in other sectors, even if something is leaked, that's fine, it's not a big private data. So again, every sector has its own vulnerabilities. Not everything can be treated as one while dumping data on one dumping ground. And then scalability bottlenecks. As I've already given so many examples, every domain again has its own scalability challenges. It's not the same for everyone. Some domains might not need to be scalable over years, and it's fine. It does not cause a big of a problem to the AI. But on the other hand, some domains need to keep getting upgraded on a regular basis, like your mobile phones, like the technology that we are using keeps changing over years. On the other hand, my mathematics syllabus over years in school, I know it has not changed. It has not changed at all. What Pythagoras theorem it was being taught, it is the same. There is no new addition to the syllabus. So that's where scalability bottlenecks are also there, because every domain needs to be trained on the AI for in a different way. And then data ownership concerns, of course. Now, quantum computing is a revolutionary paradigm. We know it can solve certain tasks exponentially faster than classical systems, because we know that quantum computing inherently works with with the principles of quantum mechanics, that is like superposition, interference, and all of that. So it gives quantum computing a leverage over classical systems to do things faster with an exponential speed. Now, quantum assisted federated learning. So, this is actually a very, very powerful fusion of federated learning, quantum computing, and quantum machine learning. And that's how we see this as QAFL. Now, the main purpose of quantum assisted federated learning, or QAFL as you like to call it, aims to deliver uh, or preserve data privacy, improve computational efficiency, It also enhances learning capabilities, solves secure distributed intelligence, and then solves complex optimization problems as well. Okay, I think this got a bit messed up, but evolution of, so what is centralized learning? Centralized learning is the user takes some raw data, it feeds the cloud server, and then the cloud server model, and then it trains the model. Just like I said, one place, one server that is being dumped with everything, and it is getting trained. Now, how is the workflow? Users send raw data to cloud, cloud trains whatever model it has, and then the model sends back some useful information to the user. That is how usually centralized learning works. And this is a part of, and this is a part of how artificial intelligence has been evolving, and this is the stage one. The problem with this is that it has privacy risks, and privacy risks I have already mentioned. Then it has huge data transfer problem. 1 minute. Huge data transfer is a problem. If you keep sending a lot of data in one place, it would start causing a lot of traffic issues as well. And then single point failure. If something fails, the entire model is failing, and you might not be able to recover all the information that you wanted to. So relying on just one centralized model does come with its own problems. And then, of course, regulatory issues that I mentioned about. Now, let's see. Now, what are the problems? And I think, yeah, problems and some examples of this. Critical issues, privacy risks, huge data transfer costs. Huge data transfer, of course, it also comes with the cost, not just the problems that I mentioned. Single point of failure and regulatory compliance for each domain, that is very different. Now, real world examples of this are medical records, banking data. These are really sensitive information. Military surveillance and smart city infrastructure. These are very, very sensitive information that cannot be put at such risks of being, of relying upon just one piece of big model, that that if it fails, we do not have anywhere else to go to. That cannot happen. We want our medical records 24 into 7. You don't know when can an emergency arrive at any place or any place on this earth. So we need that information readily available all the time. I might go on a walk, and what if I faint and I don't have the documents with me? So if it is available online, I can fetch it immediately, or somebody who's with me can fetch it immediately. Similarly for banking data. So, and not to say military surveillance, these are top secrets that needs to be protected from any or from every eyes or hands outside the group that is working on that. So it's very important to understand where all these problems can come and how can we solve this. Then once we see that centralized learning comes with its own problems, we then move to decentralized learning or federated learning, as you call it. The entire idea of this model is to bring bring the model to the data instead of bringing the data to the model. So what does that mean? Uh, okay, workflow is there. Now you have one big model, global model initialized. So there is one big global model, which is in turn getting trained from other local models. So these local model information is being sent to the global model. The model sent to edge devices, local training performed. Similarly, as we have the global model, we have different, think of it like nodes. You have one node A, and that is in turn being connected to five other nodes B, C, D, E, and F through some edges. So all these individual B, C, D, E, and F are getting trained individually on different, say one of these nodes would get trained on banking sector, one on healthcare, one on military surveillance, one on education, one on climate. So local training is preferred, and then one model updates whatever information, only model, yeah. So these small models would update whatever information they have, and it will share it to the global model, keeping in mind all the regulatory compliances. And then the central server aggregates, updates whatever updates it keeps having from the local models. It collects all of them. Then only the useful information with right compliances are collected by the global model and kept for usage. And then the updated global model that is redistributed instead of each of these local models. So you see, things become easy. Just like in your college or my company, we have one, in my company I have one CEO, and then in your college you have some director or vice chancellor, or whatever. Now if the director is kept to do his or her job, and he or she is only asked to do everything, you only take the classes, you only prepare food for the mess, you only manage the schedules, you only look after the faculty arrangements, everything the director has to do. Imagine how difficult that would be. Instead, the director has kept other people in charge. Somebody would take care of the schedule of the faculty, and whoever is taking care of the schedule, maybe that person would assign who would take classes. And then there is faculty only to take classes. There are people in the mess to prepare food, and then there are students who come, who study, who do everything, like everything as in study, do activities. So there are different people assigned. Finances is being controlled by somebody who is an expert in finance. Administration is being taken care by somebody, college admissions and everything, who has worked in that field probably, or is new and is learning, or is the right fit for that position basically. So for every job we have a different person. We don't have one person doing all the jobs despite not having the expertise. So similarly, here also we'll have different models to do different jobs. And then once the job is done, just like in your college, the director then gets informed about everything that is happening. Oh, this is done, that is done, that is done, this is done, this is how it was supposed to go, and this is how it went. So only the useful information, once things are done, are compiled and sent to the global model. The advantages. Now, privacy is being preserved, because when you're training your local model on a particular uh, data or a particular information or sector, whatever it is, it has been told, the model is told that this information is of a particular data, and all of this is needed, and all of this has to be taken care of. All the regulatory compliances have been fed for different data in different models. So the privacy can be preserved that way. So when the information is being passed to the global model, only the useful, relevant information where privacy leaks cannot be there can be sent, can be done. This also reduces data movement, of course, because now the nodes are doing the job and only useful information is going to the global model, instead of dumping everything that these models are taking inside. Lower latency, of course, personalized learning. Yeah, this is actually the best advantage, that is personalized learning. Every node will have their own sector specific or data specific learning. Every node would be an expert in what it's doing, just like the example that we had from your college. Every faculty would be an expert. Somebody who is teaching in computer science department would be expert with codes and stuff. Somebody in the mathematics department would be expert with equations. Somebody in the chemistry department would be expert with formulas. So that is the best. So when the students learn from these same student would learn from all of this. But when that student individually learns from the teachers who are expert in the respective domains, the student would get the best out of what they are learning. Similarly, because they're getting personalized learning from each teacher, a chemistry teacher will never start teaching equations in class. So that is the best thing, because in that class a student is very nicely learning how to mix those chemical compounds, how to maybe create a benzene, how to create acetaldehyde. Very focused learning in a particular class. And then once moving out of that class, very nice, another focused learning in another subject, how to do maybe object oriented programming computer science class, that will not be taught in other classes. So the focus remains and the child is able to pick up very nicely. Then we have regulatory compliances that inherently goes with personalized learning, because see, if the chemistry teacher is teaching how to make acetaldehyde and benzene, chemistry teacher also knows what chemical compounds can come together to make an explosive, and the chemistry teacher knows that that should not be taught to kids, that should not be transferred to children. So the teacher will take care of that. Now if one teacher is only teaching everything, and he or she knows, oh, these chemical compounds mix and this that, He or she do not know which chemical compounds not to tell students to fuse together, because he or himself does not know what regulation comes with these compounds. Every compound can be turned disastrous if used in the wrong way. So it is only the chemistry teacher who can tell kids not to do this or not to do that. So regulatory compliance, which is very important, that comes with personalized learning. Yeah. So here, for quantum assisted federated learning, quantum, now see, federated learning I already told. Now, when quantum computing also comes into the picture, it is enhancing one or more components of this federated learning that is all already. So see, the main purpose of quantum computing or quantum assisted algorithms are, the idea of the algorithm is very well established. It is how it is supposed to be. Now when quantum assisted or quantum inspired or quantum native comes into picture, all they are doing is they are making these algorithms more efficient. Maybe it will take more lesser time, or it may take or it may give better fidelity, that is better efficiency. So quantum computing might come into picture, take up the B node that was supposed to cater to healthcare, and the quantum circuit would set inside instead of the node classically training, and the circuit would then train itself, give better results with give better representability of the data and all of that stuff. Now quantum computing may assist in different things like optimization, feature mapping, kernel evaluation, classification, secure communication, encryption, gradient optimization, high dimensional learning. So all of these problems or all of these algorithms Just help me where I was with my last slide. I'm sharing my screen. Uh, which was the last slide that we saw? Hello, hello, am I audible? Hello, anyone in the meeting?
Yes, ma'am, your voice is
You are audible, ma'am.
Okay, okay, okay. Okay.
Now PPT also visible, ma'am.
Sorry?
Now visible, ma'am. PPT visible.
Okay, okay. Okay, so I was just talking
It's
about
not
privacy.
audible and visible in screen.
Yes, yeah, once again, sorry. I just wanted to know what was the last slide that was visible to you. Did were you able to see this slide when I explained this? Hello, hello, hello. Just any one person in the meeting, can you please help me with the last slide that you people were able to see before I got disconnected? Okay, maybe then I'll take it from where I stopped. I'll take it from here. So I was just speaking about privacy leakage. Let me do this full screen. Yeah, okay. Okay, so I was just speaking about if I have some sensitive medical financial information, it can be very problematic if these types of attack occur, or any personal information that I do not want to come out of my mobile phone or houses. If that gets exposed, that is another big problem. And then we have computational complexity. That is, the problem is training deep learning models on edge devices. They require significant computational resources. So the challenges that come associated with this is limited processing power, limited battery life, memory constraints, and long training times that might be needed. And because of all of this issue, the impact is that the scalability gets reduced, and inefficient edge device training can happen because of limited battery life or limited processing power. If it does not have enough battery and enough processing power only, how is it supposed to process all the information and send all the information to the global server? So computational complexity is one major challenge as well. And then, of course, security threats. The problem is that in security threats, malicious participants can compromise the federated learning process. As I also said before, that if one of my node is already corrupted, that means it is corrupting the entire model that I have. It will send wrong information to my global model, and my model would be trained wrongly, and it might produce results that wrong results can be harmful for us. Now, say for example, uh, these days we are using chat gpt for a lot of things. Now I saw this meme or joke somewhere where a classic example of if wrong training goes to the global model. Now we know that chat gpt as a large language model is in turn trained from a lot of other models. A lot of individuals are telling it how to reply, how to respond. Now, the joke goes like this, that there is this man in the jungle, and he saw a mushroom. He asked ChatGPT by uploading its photo, "Can I eat this mushroom?" So ChatGPT said, "It's a mushroom you can eat." And after eating the mushroom, the man started feeling bad and realized that he got poisoned. So he says ChatGPT again, "Oh, this was not the mushroom to be eaten. It was poisonous." And ChatGPT says, "Oh, yes, you were right. It is poisonous. Please don't eat it." What do you mean by please don't eat it? It has already been fed because you fed the wrong answer in the first place. That means you were not trained right. So that is what things like that can happen. If you go to chat gpt and you say my chest is feeling heavy, what if I am having a heart attack and chat gpt says, "Oh, nah, relax, there's nothing happening," like people in a household talk. "Oh, that's not a lot that's happening. You can take a chill pill." And what if you are already having a heart attack? So if the model is not fed properly, if the model is sent only incomplete or wrong information, things can turn out to be very disastrous. And the impact would be, of course, global model corruption, because the main model is getting corrupted, because in turn the local training is only going wrong, and the predictions that would happen would be unreliable. We cannot trust the information that is coming out of the global model. Now, introduction to quantum computing. Short introduction I'll give. What is quantum computing? We know that quantum computing is a computational paradigm that uses uh, principles of quantum mechanics to process information. In classical bit, we either work with a 0 or 1, but in quantum, when we talk of qubit, we of course have a 0 or 1 to work with, and we also have a superposition state of 0 and 1, where we talk in terms of probabilities of a block sphere or a qubit, probability of that existing in 0 and 1 simultaneously. That is, it might have a 60% probability of existing in 0 and a 40% of existing in 1. Please mind that you saying that it exists in both the states at the same time is a very wrong way to represent a qubit. It exists in the superposition of 0 and 1, where we talk probabilistically the occurrence of qubit in 0 and 1. Now, the key advantage of this is that the qubits can process multiple states simultaneously, enabling exponential computational power for certain problems. As I said, when you say that you're working with 2 qubits, it means that you're working with 4 dimensions, that is 2 to the power 2. That is what it means, that it can process multiple states simultaneously and enabling exponential computational power. In simple terms, when I just said that qubit can be represented in a way where it can talk about probabilistic existence of 0 and 1 for a qubit, that means it is processing states of 0 and 1 at the same time, not deterministically but probabilistically. This is done. Now, when we say a qubit can exist in multiple states simultaneously, it means probabilistically it is able to represent information of two particular states at the same time. Now, say I have a state vector psi, and say this is my qubit, and I want to represent this. How do I write it? We write it in this way, where alpha and beta are my um, uh, amplitudes of 0 and 1, and then when you square this amplitude you get the probability. So when I was saying that the probability of 0 is 60%, that means my amplitude is under root 60%. That is, 60% is what? 60 by 100, 3 by no uh, 3 by 5, yeah, 3 by 5. So 3 by 5 is what? That is my probability of 0 existing. But under root 3 by 5 is what would be the value of alpha if I say the probability is 60%, and under root 2 by 5 would be the value of beta. And we know, as I said, alpha, if I square this coefficient, that would give the probability, because under root probability is amplitude. So squaring the amplitude gives me probability, and we know that sum of all probability is always 1. So that is the condition. Whenever you place values of alpha and beta, just ensure that the sum of their squares is 1. The importance of this is that superposition enables, because this is in a superposition state, right? 60% of existing in 0 and some 40% of 1. So this is the superposition state. And superposition enables quantum computers to process many possibilities simultaneously. If I say 50 50, 40 30, 40 60, 30 70, or 70 30, that means different information can be processed of different states at the same time. So that's one big advantage of superposition. And then we have entanglement. What does entanglement mean? So when 2 or more qubits become strongly correlated regardless of the distance between them. I don't know, but few years back, or maybe it's there everywhere, when people say that if you have a pen here and it's covered somewhere in space, they are related in some way, because the pen's cap is supposed to be with the pen. That's a very naive example or a naive way to present it. But essentially, entanglement only means that even if I cannot see something, it will behave how it is supposed to behave in connection with something that is kept very far away. So that is what entanglement is. And this property is used in secure communications, quantum teleporting, parallel information processing. This very important phenomenon is used in these applications at a bigger scale. Then the importance is that entanglement allows coordinated quantum behavior beyond classical capabilities. Classically, you cannot think how is a pen and its cap supposed to be related in outer space. But if you look at it in terms of entanglement, yes, it is related, and you cannot think of it classically. It is a very quantum way to think, which human minds would not be able to. We can only understand concepts, but if you ask me to imagine, I don't know how to imagine that. I don't know how to imagine something being in a 60 or a 40% state. I don't know. None of us can comprehend because the human minds are not built that way. But yes, some informations are how they are supposed to be. The effects of quantum interference, we did what? Superposition, we did entanglement. Now quantum interference. So quantum interference is probability amplitudes combining constructively or destructively during computation. Just like if we remember the Young's double slit experiment, where there were constructive and destructive paths that were coming out of the slits in his experiment. This is exactly the same thing. This is where I think we were first taught about quantum interference. And then the effects of this is it amplifies correct computational paths, suppresses incorrect solutions, and improves quantum algorithm with great efficiency. The importance is that quantum interference helps these quantum algorithms achieve computational advantage over time. Now, why quantum computing matters for AI? The potential advantages in artificial intelligence is that quantum computing can potentially accelerate several computational tasks in AI and machine learning. What are they? Some matrix problems, optimization problems, feature mapping, kernel computation, sampling problems, and higher dimensional learning. We saw this list previously in one of my slides as well. The key insight from this is that quantum systems can process complex high dimensional information. And why can they process? I've talked about that because of qubit being able, like 3 qubits, so 2 to the power 3, that is 8 dimensions. So because of this being able to process complex high dimensional information more efficiently than classical systems can ever do for any particular task. Now, quantum machine learning. This is nothing but integrating quantum computing with the machine learning techniques that we already have to improve computational efficiency with learning capabilities. Now, QML combines quantum computing, machine learning, optimization, and data science. We know machine learning, you know what all of this combines. We have an optimizer, we feed in data, then the machine learning steps goes on. But QML will have an extra step, that is quantum computing, that is a quantum circuit that does the learning. And the goal is to leverage quantum mechanics to enhance learning, classification, and optimization tasks as per our need. Now, in quantum computing, there are different things. We have variational quantum classifier, we have quantum neural networks. So I'll just give a rough overview. So VQC is nothing but it uses quantum circuits that are parameterized for classification tasks. The main components are a quantum circuit that is parameterized, some rotation gates, and some entanglement layers. And the training process goes like this. Quantum circuit is supposed to generate some output we know. And then the classical optimizer minimizes the loss from those outputs, and the parameters in the quantum circuit, they keep updating themselves iteratively as the need arises. Then we also have quantum support vector machines that uses quantum kernels to perform classification in high dimensional quantum feature space. The key concept that goes behind this: quantum kernel computation, quantum feature mapping, and Hilbert space representation. The main advantage that comes out of this is quantum feature map can project data into exponentially large feature spaces for improved separability. And then we have quantum neural networks that are, so see, these, there is just this word quantum that is added extra. We already have support vector machines. We already have neural networks. We already have, uh, though we don't have variational circuits, but yeah, SVM and NN we already have classically. So adding quantum to that is more like having a circuit in an algorithm. That's an extra piece of uh, model that is being added. So quantum neural networks are quantum analogs of classical neural networks. The components are quantum layers, quantum gates, and of course hybrid classical quantum optimization. The applications range in QNN, they range from classification, optimization, generative modeling, and some quantum enhanced learning tasks. Now comes quantum assisted federated learning that combines quantum computing techniques with federated learning to improve distributed intelligence by while preserving privacy. The goal is to enable secure, scalable, and computationally efficient distributed learning using quantum enhanced methods. The general architecture of this is we have a global model initialization, then we have distribution to clients, we have local quantum training happening for these clients, and then the parameters are transmitted. It is then aggregated and then in the global model, and the global update comes out of that. The key feature is that the data remains local, as in federated learning, while only model updates are shared with global. But unlike classical, here we also have local training happening in our smaller nodes. So let's see step by step. Global model initialization is the initialization phase where the central server initializes the global learning model. Possible models are classical machine learning model or a hybrid quantum classical model. The purpose is to provide the starting parameters for distributed federated learning. Then comes distribution to clients. The model distribution, the initialized model is distributed to multiple edge devices or institutions. Just like this big model gets distributed to different edges and the institutions connected with those. Example, hospitals, banks, IoT systems, smart grids, autonomous vehicles. So one big place where, so there is this thing called Ayush, some Ayushman Bharat or Ayush Bharat Seva, where we have all our information or our healthcare information stored, right? Now that is a global server, but all the information is coming from the individual hospitals or clinics, or we as single identities who are feeding information to that. So that's how example of clients are one global data where all the hospitals are connected and all the information is being fed from all these hospitals. The advantage is that distributed learning, as we've already seen, enables collaborative intelligence without centralized data collection. Then comes local quantum training. Now, quantum enhanced local training. Each of these clients or my smaller nodes performs training locally using quantum assisted techniques. Now, as we know that locally also the training is going on. Now, instead of classical training, we have quantum assisted techniques to do the training. And then what are these techniques? They can use quantum feature maps. They can use variational quantum circuits, hybrid quantum layers, quantum optimization, different techniques. And the benefit is that quantum models may improve feature representation and optimization efficiency. And we know why, because of better data representation in a place where we can work with higher dimensions. Now, transmission of parameters, privacy preserving communication. Only model related updates are transmitted to the central server, and these information can be different parameters, gradients, or quantum circuit updates that we have individually. The privacy advantage is that raw data never leaves the classical device. It is only the processed data that goes to the global server. Now, step 5 and 6, aggregation and global update. Aggregation is central server aggregating or putting together the updates received from all participating clients. Possible aggregation methods are Fed average, quantum aggregation, secure aggregation, or blockchain assisted aggregation. And the global update, the improved global model is redistributed to all clients for the next training round. Now, quantum components of quantum assisted federated learning. We have different components that can be used for the node trainings. We have quantum kernels. The purpose of that is to have high dimensional feature mapping, variational circuits for learning complex patterns. QAOA is for optimization. Quantum annealing is for combinatorial optimization. Quantum encryption for security enhancement, and quantum randomness for secure communication. The importance, these quantum computers enhance learning capability, optimization efficiency, and security in quantum assisted federated learning. Now, let's look at the domain applications. Now that we have understood all these uh, basics or fundamentals or whatever the background of QAFL, let's very quickly go towards different domain applications of this QAFL. First, let's start with the primary application, that is healthcare. Why healthcare needs QAFL? Because now that you know how a federated learning model is trained classically and in a quantum space, we need QAFL because medical data is highly sensitive, distributed across hospitals, and regulated by strict privacy laws. So, for that, we need a model that caters to all of this. The challenge is hospitals cannot easily share raw patient records due to privacy and regulatory constraints. So, individual hospital would be their own training notes and they would choose what information to share to the global server. They cannot just go and dump all the restricted information that they have. Now, healthcare application, disease prediction is one of them. Collaborative disease prediction. Hospitals collaboratively train machine learning models without sharing patient data. Again, as an individual node, they know how and what to share, keeping in mind the regulations and the privacy. Application, QAFL is used in cancer detection, brain tumor analysis, diabetes prediction, and heart disease prediction. Not to say that the advantage is it enables secure collaboration while preserving patients' privacy. Now, healthcare application in medical imaging. Quantum assisted medical imaging. Quantum enhanced deep learning models can improve medical analysis. Possible applications in magnetic resonance imaging analysis, or as you call it, MRI analysis, the CT scan analysis, or X ray diagnosis. Benefit, quantum assisted convolutional neural networks, or CNNs, may improve feature extraction and diagnostic accuracy. Now, healthcare application or drug discovery. Now, quantum computing for drug discovery, another use case in healthcare only. So, now see, in healthcare only, we saw all of this: disease prediction, medical imaging, drug discovery. So, in drug discovery, quantum systems can simulate molecular interactions more efficiently than classical systems. And the role of federated learning, this enables secure collaboration among pharmaceutical companies, preserves proprietary and sensitive research data, and supports distributed drug discovery pipelines. And the impact is that it accelerates discovery of new drugs and treatment methods. Benefits of QAFL in healthcare: major advantages: privacy preservation, faster diagnosis, better model generalization, reduced computational complexity, and of course, secure multi institution collaboration. So, QAFL enables intelligent, private, privacy preserving, and scalable healthcare systems. Domain applications of QAFL, that is smart grid and energy systems. We just now saw healthcare. Now we'll see smart grid and energy systems. Smart grid and energy applications, the importance: modern smart grid generate enormous amounts of real-time data. Major data sources: smart meters, solar plants or panels, like solar plants are a bigger version of solar panels, wind farms, hydropower stations, and industrial sensors. Smart grid applications or in energy demand forecasting. Now, energy demand prediction, in that we use QAFL, which can collaboratively predict future energy requirements. Remember, I told while we were beginning this session in this only, like when we saw a smart grid application, that there are areas that do not need a lot of electricity in the same city, while there are areas that need enormous amounts of electricity. So we also need QAFL to be able to predict the future energy requirement using distributed energy data. Prediction targets: peak load forecasting, seasonal demand prediction, and renewable energy fluctuation. Benefit: improves grid stability and efficient energy distribution. Now, in smart grid application only, we also have fault detection, distributed fault monitoring. Now, distributed substations collaboratively identify faults across the power network. The probable detected problems could be transformer failures, grid instability, and transmission faults. The advantage: enables faster detection and respond to grid abnormalities. Optimization of renewable resources. Quantum optimization techniques can improve renewable energy management. Optimization tasks, optimal solar wind energy mix, energy storage scheduling, and trying to minimize the cost, yet being able to produce the best that we can. Impact, it of course improves efficiency and sustainability of smart grids. Now, what are the challenges in energy optimization? Why quantum computing helps in energy optimization? See, energy optimization problems are often high dimensional because so many nodes to work with. They are non-linear and NP hard. NP hard means it does not, like, it cannot be solved in polynomial time. Quantum advantage, quantum optimization problems may provide computational advantages for solving complex energy problems. Domain applications of QAFL, finance and banking. Now, finance and banking applications, this is third that we are coming into. We saw what? We saw healthcare, we saw smart grid energy systems, and under that, we saw different use cases. So, we've covered almost 5 to 6 now. Let's move to the third domain, finance and banking and its application. Now, challenges in financial artificial intelligence. Financial institutions face several critical challenges that are fraud detection issues, privacy concerns, regulatory restrictions, and cybersecurity threats. Finance applications or fraud detection. In fraud detection, now, probably this is the seventh or the probably the seventh that we are seeing. How many did we see before? We saw 1, 2, 3, 4, 5, 6. We already saw 6. This is the seventh use case that we are seeing in the third sector. First one is fraud detection, collaborative fraud detection. The banks collaboratively train fraud detection models without exposing customer information, because what else is sensitive to us more than money? We are the most that we are concerned, even more than our health. We are concerned about the money that we have. So banks, they need to train their models to be able to not fall prey to the to any sorts of money laundering or frauds that might happen. Role of quantum models in this: they detect subtle fraud patterns, improve anomaly detection, and enhance predictive performance. Benefit: it improves financial security while preserving customer privacy. Now, eighth application, credit risk analysis. Now, privacy preserving credit risk analysis. Financial institutions collaborate by sharing learned parameters instead of raw customer records. Advantages: improved risk prediction, regulatory compliance, and secured distributed learning. Impact: enhances decision making while protecting sensitive financial data. Then comes portfolio optimization, the one of the very popular problems in the world of finance. Quantum financial optimization. Quantum optimization methods can improve financial portfolio management. The optimization task that goes inside asset allocation, risk minimization, and market forecasting. Advantage: quantum algorithms may solve complex optimizations more efficiently than classical algorithm can ever do. Then comes QAFL in cybersecurity. This is the fourth domain and probably the ninth use case that we'll see. Cybersecurity application. Importance: modern cybersecurity systems require real-time learning, distributed threat intelligence, and secure communication. Cybersecurity application: intrusion detection systems. The collaborative threat detection. Distributed devices collaboratively learn attack signatures using federated learning capabilities, real-time intrusion detection, distributed anomaly analysis, and threat intelligence sharing. Benefit: it improves network security without centralized data collection. Privacy preserving malware analysis. Organizations collaboratively train malware detection models while keeping internal systems private. Advantages: shared threat intelligence, enhanced malware classification, and reduced exposure of sensitive infrastructure. What is the impact of that? It strengthens global cybersecurity defenses through collaborative learning. Now, I think this is the fifth application, QAFL in climate sciences. We saw healthcare, we saw banking, we saw cyber security, we saw energy grid optimization. Yeah, this is the fifth application. QAFL in climate sciences. Now, climate modeling involves massive computational complexity because the applications range from weather forecasting, climate simulation, disaster prediction, flood forecasting, wildfire monitoring, and carbon emission analysis. The different meteorological centers can collaboratively train climate models without exposing raw regional data sets. Quantum computing may help solve highly non-linear atmospheric equations faster than classical systems. The QAFL in space research, space systems continuously generate massive. So these were the applications or use cases in climate sciences. Now, QAFL in space research, space systems continuously generate massive data through satellites, deep space probes, ground stations, and remote sensing devices. Applications in space research. First one, satellite image classification. Now, distributed satellite stations collaboratively train models for land use analysis, border surveillance, environmental monitoring, and oceanographic studies. Then we have space debris prediction, where quantum optimization may help predict orbital collisions, debris trajectories, and satellite positioning. Then we have autonomous space exploration, federated intelligence among Mars rover, lunar stations, and orbital satellites that can enable distributed autonomous learning. Then we have QAFL in telecommunications, seventh area of use case rather. Telecommunication systems generate enormous real-time traffic data because all the time in very naive language, we are on call for so long. This is a call. After this call, maybe somebody would call them every time, every single second. There are thousands of people on call. So applications include network optimization so that the Airtel, say for example, there is only one network, that is Airtel, and all of us are using it. It has to optimize its network so that 10 people call together, and network and Airtel cannot say that, oh, I cannot handle so much overload, I cannot take so many people calling at the same time. What if two of them had emergencies and they were only not able to call? So network optimization is very important. 6G intelligent routing is very important. Congestion prediction, signal optimization, and dynamic bandwidth allocation. Now say I Airtel does not know in the next second on an average how many people can call. They cannot, if they don't have congestion prediction, that would be such a disaster. We only think in terms of health and money, but this health and money are related to so many things in turn. What if there was a fraud on happened on your credit card and you had to call the bank to stop it, but you couldn't because Airtel couldn't take so much of traffic. So a lot of things go behind all of this. So quantum assisted optimization may improve spectrum allocation, routing efficiency, and of course energy consumption. Now, QAFL in supply chain logistics. Modern logistics systems are highly distributed. Data sources include warehouses, transport fleets, retail stores, ports, and IoT tracking systems. Applications in supply chain. Now, organizations collaboratively train models for inventory prediction, demand planning, and warehouse optimization. Then comes route optimization. This is a very well-known problem in supply chain. Quantum optimization can improve delivery scheduling, fuel minimization, and multi-vehicle routing. Now, cold chain monitoring. Distributed Internet of Things or IoT devices, they monitor what? They monitor our temperature, humidity, transit conditions without centralized exposure to the operational data. Next. Now, let's see classical federated learning versus quantum assisted federated learning. Let's start one by one with individual features. First feature space. Classical federated learning is of course classical, and quantum assisted we have quantum Hilbert space. For optimization we have classical optimizers. For quantum we have quantum enhanced optimization. For security, we have classical cryptography. For quantum, we have post-quantum cryptography. For pattern recognition, we are limited by classical complexity, but the potential gets enhanced when it comes to quantum. Scalability high, but it is very communication heavy in classical federated learning, whereas the potential has improved a lot in quantum federated learning. And computational power is, of course, the classical hardware. And for quantum, we have hybrid quantum as well as classical. I think we can skip quantum encoding methods because we don't have a lot of time left. We can just jump into the QAFL part. So quantum, and because see, we have a classical data and we want it to run on quantum circuit. So these encoding methods just tell us how these classical data is encoded on a quantum circuit that in turn runs on a simulator or quantum hardware. Now, entanglement enables correlated quantum states, potential advantages, faster information representation, complex dependency modeling, and enhanced feature interaction learning. Applications range from medical imaging, financial forecasting, and cybersecurity anomaly detection. Then we have communication efficiency in QAFL. Communication is one of the largest bottlenecks in federated learning because, of course, after training, each of these modes need to uh, go or get communicated to the global server. So, quantum assisted approaches may reduce communication through compressed parameter exchange, quantum state representation, and, of course, efficient optimization convergence. Client selection in federated learning. Not all clients participate equally. Challenges: limited bandwidth, battery constraints, computational limitations. Quantum optimization algorithms may help determine optimal client subsets, efficient scheduling, and dynamic participation strategies. Adversarial attacks in federated learning. First one, model poisoning. Malicious clients, as we discussed, if the node is only corrupted, then the global model is going to uh, give out wrong information. So malicious clients or nodes manipulate updates, data poisoning. Attackers inject misleading training data on the local model itself. And then backdoor attacks, that is hidden malicious behavior inserted into the models. How QAFL helps security. Now, QAFL may enhance security through quantum randomness, quantum safe encryption, advanced anomaly detection, and secure aggregation protocols. Now, in this era that we are in today, so we currently live in the NISQ era, that is noisy intermediate scale quantum era. The characteristics are we have very limited qubit counts, there is high noise, and a lot of decoherence or instability, however you like to call it, and short coherence time. That is very short stability time when the qubit is supposed to give out any information. Now, there are various quantum hardware platforms like IBM, Google, IonQ, Rigetti, D-Wave, and each of there are many more. I've just listed a few. And each of these organizations work with different kinds of qubit technology. For example, IBM works with superconducting qubits, Google works with superconducting qubits, IonQ works with trapped ions, Rigetti works with hybrid quantum systems, D-Wave work for quantum annealing. Real world barriers to QAFL adoption. Hardware cost. Quantum computers remain extremely expensive. And there is also a shortage in skilled workforce. QAFL requires expertise in quantum physics, machine learning, distributed systems, cryptography, and optimization. And the additional barriers, we also have lack of standardization. No universal QAFL protocols currently exist. Like in post-quantum cryptography, we have NIST protocols that work for different algorithms. We don't have that for QAFL. And we also have limited quantum advantage proof. That is, many systems still need experimental validation for true quantum advantage. Emerging research trends, federated quantum neural networks, distributed training for quantum neural architecture, quantum transfer learning, transferring learned quantum representation across domains. And then we also have blockchain along with quantum assisted federated learning. That's the best combination because blockchain itself is decentralized. So combining blockchain, federated learning, and quantum security for decentralized trust systems. Advanced research directions, you can look into quantum edge AI, that is lightweight quantum intelligence at edge devices, and quantum federated reinforcement learning, that is multi-agent distributed quantum learning systems. And then we know that QAFL is very interdisciplinary in nature. As we saw, there are so many use cases across different sectors. In quantum, so the domain quantum computing, it contributes as for quantum speed up, machine learning for pattern recognition, and the entire system has been set that way. Federated learning for distributed intelligence, cyber security for secure communication, mathematics is needed for optimization theory, and physics is needed for quantum mechanics, while cloud computing contributes to the distributed infrastructure that we have. Mini case study, smart energy systems. This is probably one of the last slides that we have. Now, a case study, let's see. Now, let's imagine a scenario that there are multiple smart cities collaboratively predicting some electricity demand. Now, each city, contains some smart meters, some renewable energy sources, different consumption patterns, and distributed grid infrastructure. Now, we've taken a scenario and we know what a city contains. Now, let's look at the problem. The problem statement. Now, cities cannot directly share raw energy data, raw energy consumption data because of privacy regulation, infrastructure limitation, and secure concerns, and also competitive operational constraints. At the same time, accurate demand forecasting is essential for grid stability, renewable integration, load balancing, and cost optimization. Now, QAFL based solution. The system uses quantum assisted federated learning. The workflow goes as follows to solve that problem. Now, we know how the usual workflow is. Let's see in this case as well. Global model initialized at central server. Model distributed to smart cities. Each city performs local training. Quantum optimization improves learning efficiency. Only model parameters are transmitted and global aggregation is performed. Raw energy data never leaves local infrastructure. Quantum components used. Quantum techniques that can be integrated into the system are quantum feature mapping, variational quantum circuits, quantum optimization algorithms, and quantum kernel methods. Now, these methods help analyze higher nonlinear energy consumption patterns. Benefits of QAFL in smart energy systems. They have better forecasting accuracy. They have lower communication overhead, enhanced privacy preservation, improved renewable energy integration, faster optimization, and increased grid stability. Potential applications also include national smart grids, industrial energy management, smart city infrastructure, and renewable resource balancing. QAFL enables multiple distributed energy systems to collaboratively learn intelligent forecasting models while preserving the privacy, that is not sharing the raw data, and improving optimization efficiency. That is QAFL is a combination of privacy, distributed learning, and quantum optimization in this energy sector case that we took. Now, important terminologies for audience: qubit, that is quantum bit; superposition, that is multiple simultaneous states; entanglement, quantum correlation; Hilbert space, that means quantum feature space where we represent our problem statements or whatever we have, our problems; variational circuit, that is a trainable quantum circuit; quantum kernel is used for quantum similarity measure; NISQ, that was already mentioned, that is noisy intermediate scale quantum; and Fed average is federated average algorithm. Now, let's look at some perspectives. Indian perspective on QAFL. India is actively investing in quantum technologies, AI research, semiconductor ecosystem, cyber security, and smart infrastructure. Important initiatives include National Quantum Mission, India AI Mission, Smart Cities Mission, and Digital India. Potential Indian application. They can include smart agriculture. We know that India, a lot of population in India are dependent on agriculture. So what if we could use these technologies for smart agriculture, maybe get farmers a better life, because farmers in Australia, US, they are very rich. Why not our farmers get that? National healthcare networks, power grid optimization, defense intelligence, and of course financial fraud detection. Now let's conclude. See, quantum assisted federated learning is gradually emerging as a foundational architecture for next generation intelligence system. Its importance lies in combining the previous in combining first privacy that we have, so preserving the privacy, distributed intelligence being learned by different nodes separately, keeping in mind regulations. So distributed intelligence, advanced optimization technique, and quantum computational principle to train the models better. Now, as quantum hardware matures, because currently we are in NISC era, we have a lot of noise and decoherence and very less coherence time, and very less logical qubits as well. So we are not where the entire potential of quantum hardware has been realized. So as quantum hardware matures, QAFL may redefine how data is processed, how a model is trained, how organizations collaborate, and how secure AI ecosystems operate. Now, paradigm shift in computational sciences. The transition from centralized artificial intelligence to federated artificial intelligence are eventually to quantum assisted, and eventually from, see, we started from centralized AI. So we have an AI, we know, oh, we need to train a model, blah, blah, blah. And then we understood, oh, what if that is very problematic? What if we can train local models and then feed to the global model, and then global model can send back information, and iteratively we can learn. So the concept of federated AI came in. Now, to make this even better, to make the model training better, we eventually move to quantum assisted federated intelligence that represents a major paradigm shift in computational science that we actually study today, that is taught in colleges and schools. So the future of intelligence will not belong to isolated machines working independently. It will belong to collaborative, privacy preserving, quantum enhanced ecosystems capable of learning securely across the entire digital world. One person or one machine will not be doing everything. It would be a combination of the best that we can get out of the computational ecosystem that will surely learn the best from the entire digital world. So I guess that is for my session. I have a few. I kept this slide to interact with the audience. I just wanted to know your POV or your point of view as well. On, I gave my point of view. I gave what I think about all of this, what all of these are. Now I want to know from you people what you think. So my first question was, do you think can privacy preserving AI become mandatory in future healthcare systems? Anyone can unmute themselves and speak. I'll maybe wait. Okay. Let's stop sharing first. Let me. Oh. Can somebody just pin my screen? Share. Can someone can now see your screen? No, no. Hello, is anybody there? Can you help me with this? Hello, hello.
Yes, ma'am.
Can you just pin my screen for everyone? I'm sharing my screen. I just want it to be pinned here. I don't know how that can be done. So I see Dr. A. Anna Lakshmi, Associate Professor's profile here on the big screen. I want that to be my screen here, the screen that I'm sharing. Yeah, this one. Yeah, thank you so much. Okay. Uh, Thank you. So these questions are actually for the audience who are sitting here. So can anybody unmute themselves and tell me your I just want to talk about opinions on any of these questions. Maybe will quantum computing redefine cybersecurity standards? Do you think so? Can distributed intelligence outperform centralized intelligence? Or what domains in India can benefit most from QAFL? Or is current infrastructure ready for quantum enhanced AI? Anyone can unmute themselves and talk about it. No one. I just wanted to have a little bit of interaction also with everybody.
Dear
Just your
participants,
point of
it's the
yes.
time for interaction. Dear
Yeah.
participants, if you are having any doubt, you can ask Aditi Lal ma'am. So they don't have any doubt, ma'am.
That's really
Your
nice.
session was excellent.
Thank you.
Okay. No.
Uh,
Okay. Good
so
morning
I
to all.
Yeah.
Stuck ஆயிட்டு எனக்கு.
Yeah, ma'am, you can please go ahead.
Yes.
If somebody was speaking something, please go
Ma'am,
ahead.
On behalf of our institution and organizing team, I would like to express our heartfelt thanks to our esteemed resource person, Ms. Adilal Ma'am, for delivering such an insightful and inspiring session on domain applications of quantum assisted federated learning. Your presentation gave us a deeper understanding of quantum computing, federated learning, and their real world applications in scientific computing and optimization. Thank you once again, ma'am, for your wonderful session. Thank you, ma'am. Thank you. Thank you so much, ma'am.
Thank you, everyone. Bye bye. Have a good day.
Okay, ma'am. Thank you, participants. Participants are requested to fill the attendance feedback link immediately. Let's break for tea. Join back at 11 a.m. for the next session.
Total system idayitu.
எக்ஸ்ட்ராவா என்ன ஒர்க் அடிச்சுட்டு இல்ல அவங்க அதை மியூட் பண்ணிட்டாங்கன்னா அதனாலதான் அவங்க இன்னும் அந்த லைன்ல இருக்காங்க அது பண்ணி
அப்ப கேஷாவே கொடுத்துட்டு போக வேண்டியதானே?
Yes, Professor.
Good morning.
Good morning, sir.
Good morning, ma.
Sir, will make a co-host.
Sir.
Sir, name. We'll make him as co-host.
Good morning to all the respected dignitaries, faculty members, and participants. It's my great privilege to introduce our esteemed resource person for today's session, Dr. Janardhan G, Professor at NITTTR Chennai. Dr. Janardhan Sir brings over 25 years of expertise in civil and geo-environmental engineering and transformative engineering education. His work integrates technical research, pedagogical innovation, accreditation, and sustainable development. His core areas include outcome based education, academic auditing, MOOCs, water quality, lake remediation, sustainable construction materials, waste management, landfilling engineering, and smart cities. He had coordinated more than 25 international training programs for 450 delegates from 68 countries and trained over 15,000 participants nationally. A pioneer in digital education, he developed 13 MOOCs with enrollments exceeding 50,000 and secured 15 crore funding for Swayam initiatives from the Ministry of Education. Dr. Janathanan sir has received research support from the World Bank, DST, and the Ministry of Education. Today, he will be delivering a session on the highly relevant and transformative topic National Education Policy 2020. We are indeed honored to have such a distinguished academician and educator with us today. On behalf of everyone present here, I extend a warm and heartfelt welcome to Dr. G. Janathanan sir. Sir, we are delightful to have you with us and look forward to an insightful and inspiring session. Now, I request Dr. Janathanan sir to kindly take over the session and share his valuable insights. Please, sir.
Are you there, madam? Suddenly voice.
Yes, sir.
Yes,
Yes,
Professor.
sir.
Good morning.
Yes, sir.
Professor,
Good
good
morning.
morning.
ஆரம்பிக்கலாமா? திடீர்னு வாய்ஸ் கம்மி இருக்கு. இல்ல இல்லாம இருந்ததுக்காக தான் கேட்டேன்.
இல்ல
Yes,
சார்
sir.
ஆரம்பிக்கலாம் சார் ஆரம்பிக்கலாம் சார்
You can start the session, sir.
Good morning. On behalf of NITTR Chennai, I thank the organizers of RMK for inviting me to deliver a lecture on National Education Policy 2020, a transformative document which paves the way for the Vikshit Bharat, because that is the beauty of this document, because education is a root cause for everything. The ecosystem gets transformed or ecosystem becomes sustainable only with a proper education system. That is the truth. Even if you have seen that movie where Dhanush will be advising his son in the last climax scene, they can take everything away from you, but not the education. So that is the beauty. And as an individual from a developed country, developing country, we have been fine-tuned with the concept. If you have a proper education, your life will get settled. That is the thought process. So the education, one thing to enhance our thought process and knowledge. Second thing, to get a good job opportunity also, we get the education. So, but is it producing a holistic engineer, a holistic thought process? Or is it producing a value system? Is it producing ethical aspects? This becomes a big question because recently one of the very famous deemed to be university, which is the top 10 in the era, we were discussing with this. I was involved with them in one of the work where I told them that because they told why these are all are to be included in the critical thinking. Whether we studied critical thinking, are we not aware about critical thinking? That was the question he was asking. I said, okay, I told him, you just do this activity and see yourself how you felt. Because this activity, when we are given to our age people, the people will do it. But the next generation or the latest generation, Gen Z or the what who are the youngsters, they never did. So I said, this is the reason for having a critical thinking as a subject. Because the content is same, but you have to see at what time you are handling. Because in the examination, I tell why we have to keep examination in the morning or evening, afternoon. We discuss the same place. If you see the Google map, morning it will be of this much time, 1 hour. Afternoon they might show in 45 minutes. Evening it might show 2 hours. Is it the same place is going away and going coming near? No, nothing. This place is the place. But the distraction and disturbance are more. So as students, the students are having more disturbance and distraction these days. So we have to eliminate everything so that the connectivity has to be established. That lies with the teachers. That is what NEP talks about. NEP exclusively focus on 2 chapters on teacher. 2 chapters on teachers. So with this, let me share the screen and let me start the presentation. Let me share the screen. Let me share the presentation. I hope the screen is visible to the participants.
Yes, sir, it's visible, sir.
Okay. So if you see the beauty of National Education Policy 2020, after 1986, this policy got launched. 1986 till 2020, we didn't have any policy. There was amendments for the 1992 Common Minimum Program, Sarva Shiksha Abhiyan. There are some amendments where that little bit additions and deletions were there. Additions are not deletions, but it has not transformed much. The 2020 only, the transformative document came. But the beauty of the NEP 2020, if you see, there are 4 parts are there in NEP 2020. 4 parts, and there are 27 chapters are there in NEP 2020, National Education Policy 2020. 4 chapters, நான்கு திசைகள், நான்கு திக்குகள், நான்கு வேதங்கள், anything you can take it, 4 and 27, 27 நட்சத்திரங்கள் இருக்கு. So 27 chapters are 27 chapters and 4 parts. And you have to see the wonderful beauty of NEP 2020. The NEP 2020 starts with one of the good essence of the couplet provided in the Tirukkural, provided by Thiruvalluvar. எண்ணென்ப என எழுத்தென்ப இவ்விரண்டும் கண்ணென்ப வாழும் உயிருக்கு. Very nicely they have told. The letters and the numbers are the 2 eyes of the living beings. This is what the chapter of NEP 2020 starts. NEP 2020 starts with the notion the letters and the numbers are the main crux which everyone should need to be there. This is what Thiruvalluvar also told in his Tirukkural. எண்ணென்ப என எழுத்தென்ப இவ்விரண்டும் கண்ணென்ப வாழும் உயிர். So for any living beings, the numbers and letters are very, very important. And how you look the numbers and letters are also matters a lot. So let us discuss NEP 2020 next 90 minutes in a manner which is possible. And I request many of them to discuss and deliberate it, because the powerfulness of our education system predominantly lies in debate and deliberation, not in accepting the things. That is what this NEP 2020 tried to focus, because the focus is, it is not the focus of this thing, it is the focus of how we have to go about it. That is a beauty which you have to remember. So in this situation, we have to remember how we have to take care of the system. Because NEP provides an opportunity for us to look things holistically and get into Indian-centric education system. Predominantly now we are focusing on a decolonization of a curriculum. Because we are now following what someone has told, we are accepting it. We are not having the thought process of why and why it should be like this, why not, you know. But only in our philosophy we can question whether that exists or not. Whatever you are telling, how it is true, you tell me that way. So that freedom is there, because in some places we don't have that freedom. Whatever has been told, it has to be accepted or acknowledged and taken into consideration as such, because there is no other scope for accepting the things. That is the beauty that you have to remember. So in that situation, how to go about it, what are the ways and means which you have to do it. So what are the effects which we are going to take into consideration? What are the effects which you are going to take into? So in this lecture, the content expressed are purely my technical perspective. It does not represent the organization with which I am affiliated. That is the first disclaimer I wish to make it, because this is what I want to tell, because this is no way connected with this thing. Whichever we are telling, it is based on the our perception and our reading, and but we cover only authenticated and validated content. We never cover the other content because nowadays I'm seeing several people are teaching, several people are doing it, and whatever subjects if they ask, they will we will handle it. But you have to remember, is it authenticated or validated? That is what. Uh, this is a first slide. Generally in NAP lectures, I used to put in my all my shows and everything. When I go to the class, I want to be exposed to new ideas. I want to experiment with my understanding of these ideas. If something is confusing, I want to able to ask questions. If I find something mind blowing, I want to talk about it. A lot I want to know if it means the same to others or why it doesn't. I always want to know why. I want to have a deep insights that matter to me. I want to be excited, inspired, and encouraged. I want to be seen. I want to be able to use what I learned and to share it with my world. This is the crux and the feeling and of any individual student. But let us decode this thing very purely in a critical manner. Whether the students are in the position to learn and share what they learned with the world, if I ask any question, sir, you don't understand, sir, because no, even the novice need to get understand what you have learned. That is the beauty of education system. But unfortunately, the students are not in the position to give a clarity about what branch they are studying or what way it is different. Sir, adan sir, idan sir, like that they are telling. They don't have a clarity. But they always want to get excited. They always want to be seen. They always want to get encouraged. This is what has been discussed in the graduate attributes and professional competency. And this is what discussed in the NDP 2020 in depth. When a teach community of inquiry model, we tell the three presence are needed for teaching to take place, learning to take place. One is social presence. Second is cognitive presence. Third is a teaching presence. Social presence. What exactly I mean by social presence? The social presence I mean the students need to exhibit their presence. That what? I want to be seen, I want to be heard, I want to be excited, inspired, all those things. But unfortunately, if the students ask questions, you keep quiet. And if the dull student asks questions, we always, these are the words which sometimes with poison coated words which the teachers do, which creates a problem. You remember? Ethics is not at all existing. That is the beauty because if you commit, you have to commit to the words. The people are investing the time and energy means you have to give a due respect. It's simply we are not giving because I know how the people are charging and how the people are doing everything I know. Because sometimes we help some colleges for something because they take it in a granted manner. That is what the which feels the hurted, you remember. But we are not bothered, but we are not continuing. That is a different story. But the reason is everything need to be acknowledged. Everything need to be duly respected. That is what needed. So the purpose of national education policy to instill the value system among the students, ethics among the students. As I told you, there are four parts are there. The first part, chapter number 1 to chapter number 8, talks about school education system, which is not the objective of this lecture. This lecture predominantly focus from part 2, that is chapter number 9 to chapter number 19 in focus. Then comes the part 3 to make it happen. That is other areas of it, other key areas. What are the other key areas? Chapter number 20 talks about professional education. Chapter number 21 talks about adult education. Chapter number 22 talks about promotion of Indian language, culture, arts, and culture. Chapter number 23 talks about the technology, online learning, and the chapter number on the technology usage, use of technology. Chapter number 24 talks about the online and distant learning. And make it happen is 25, 26, and 27. This is the way the flow goes. So now we are going to focus on each chapter in depth because, as I told you, it is predominantly Indian centric education system path to transformation. Because in this philosophy, we are not asking you to accept it, we are asking you to come to a conclusion based on debate and deliberation. It's a philosophy. Philosophy means there might be n number of philosophy. Each philosophy is right in this own direction, and each one might be accepting their philosophy. That is one beauty of the philosophy. It doesn't mean that I am also right, you are also right. I am respecting you are right, and you are respecting I am right. That is what the this policy speaks. It doesn't always speaks I am only right, you are wrong. No, that is not our culture. That is not our education system. Our education system, you are also correct, I am also correct. Let me respect you, let me respect me. That is what the beauty, that is what the Siddhi. Now, educational institutions does not mean student will learn. Yes, of course. In the education institution, only the students are learning. Even beyond education learning, I am seeing several systems, Code Tantra, IM Neo. There are several things where the students have been provided an opportunity to make a self-learning. That is also beauty. Then comes learning does not mean the students will have a skill for the labor market. That also you should remember. Since you have learned doesn't mean that you have a skill for the labor market. Having skill does not mean you will have a job. That is also one of the beauty which you should remember. Since you have learned doesn't mean that you will have a job market. So it is a complex route which you have to accept and acknowledge it. So, but one thing you have to remember, this is the most important time to be in the education. This is the most important time to take care about the education. This is the most important time to create impact in the education. There are challenges are there and solutions are there. The solution is to find the mismatch, and it is not focusing on the content like Western philosophy. It is focusing like our now the ancient philosophies to connect it to the context, connect it to the context. That is the ancient philosophy which we have to focus in. But let us together explore the NEP 2020. But the students are completely blindfolded in NEP 2020. They are not worried about what is NEP 2020. You remember, recently we have been to one university. Myself and Anbut, we were discussing, we are delivering lecture. The students are of different. Anbut was discussing important part, they were not listening it. Then my turn came. I told him, you remember, you might be youngsters, you might be having a value system of different. But one value system of our Indian culture is whoever speaks, you respect the speaker and listen to them. Consciously listen to them. They are investing their time. And it is a blessing. If you think you are much more important, no problem, you better you can go. Don't sit for the attendance. Then I asked a few questions. Are you aware of this answer? They don't blink, they're blinking. This is what covered in professor speech. Why you didn't listen? So the students are completely, they don't know about choice-based credit system. Why you need a choice-based credit system? They are not aware. But choice-based credit system has been discussed in NEP 2020. Because there is an exclusive chapter number 12 which talks about optimal learning environment and support to the students. How we have to support in terms of scholarship, in terms of fellowship, in terms of Vidya Lakshmi loan, education loan without collateral. So the chapter number 12 talks about optimal learning environment, how we have to support the students. So that is your responsibility to know, and it is your right to question. That is the beauty of the system. But where is the key? That is the question which we have. Problem is there with the law, but where is the key? Key is implementation of NEP 2020. As I told you, one of the constitutional amendment they make it to make the education to concurrent list, which resulted in the both central and the state this thing. That is the beauty. So it is impossible to redesign students to fit into a system, but we can redesign a system for the students. This is what the crux of NEP 2020. I am aware I cannot redesign students to fit into a system, but I can redesign a system for the students. I can redesign a system for the students. That is what NEP 2020 talks about. NEP 2020 talks about. I can redesign the system for the students. How we can redesign? What are the ways and means which we can redesign? What are the ways and means which we can redesign? That is what the importance which we have to focus. Because redesign doesn't comes very easily. It has to be accepted. So the students, what are the need and how when we decide something, we cannot design for the tomorrow. We have to design for the next few generations how it operates. That is the beauty. This is what that's a beauty of the educational system. So it is not how you operate for the current scenario, it is how you operate for the future generation. So that is the way the beauty goes, and that's the way it has been designed and it has been. So national education policy is the major transformational reforms in the educational sector. What they mean? Because if you see, it all started with Radhakrishnan Sir committee, and then it resulted in the formation of UGC, and subsequently the committees have been there. The first committee which talks about this Kothari's committee, 1968, which talks about radical restructuring and equalizing educational opportunities, which eventually resulted in a special emphasis on the removal of disparity, 1986 education policy to equalize educational opportunities. 1992, there was a focus on common minimum program. In 2020, you have been provided with the NEP, which discuss about the curriculum basically, which talks about reduce the curriculum content to enhance essential learning, critical thinking, more holistic, experiential, and a discussion-based, analysis-based learning. Discussion-based, analysis-based learning. That was the focus. That was the focus which you have to remember, and which you have to operate it. So as I told you, University Educational Commission 1948 and 49, Radhakrishnan sir, based on that which created, and 52, and Educational Commission under Kothari was formed 64 and 66, which resulted in the National Education Policy 1968, the 42nd Constitutional Amendment in the year 1976 made education in the concurrent list. 1986, they released the Education Policy again and modified in 1992 with a minimum common program of action of 1992. Later on, there were two committees where the Subramanian Committee report was the TSR, and then Dr. Kasturi Rangan sir committee was there in 2019, which paved the way for current NEP 2020. These two committee report paved the way. But what issues which were there? Because if you see, as I told you, there are 4 parts are there. Part 1 school education, part 2 higher education, part 3 other key areas of focus and making it impact is part 4. If you see the part 2 higher education, chapter number 9 talks exclusive. One of the very smallest chapter 9.1 to 9.4, only 4 subunit, where it talks about the issues in the higher education system. Because it talks about quality university, that is the main crux in the 9th chapter. What are the issues? Around 10 issues have been listed. That is fragmentation of higher education system. Several fragmented higher education systems are there. And this fragmentation and too many silos, rigid separation of disciplines, with each specialization streaming of students into narrow area of study, everything. But what happened? It resulted in the less emphasis on the development of cognitive and learning outcomes. Especially the lack of access of socially economical disadvantaged areas. That is the reason NEP 2020 talks and it tells every district should have a higher educational institution by 2030. Very critically, it has told. This has been witnessed. Yesterday, I went to Noida for some inspection, where we have seen a The Greater Noida is continuous school of colleges, different colleges, different colleges. It becomes an education lab. It is a one perspective for industrial lab or business area. It is suitable. But education is not a business area. Education is an enlightenment area. Enlightenment, you cannot put all the lamp together. The lamp has to be kept at different locations. Then when the lighting will be, entire area will get lit. That is the beauty of the lighting. Remember. But what I observed is there all lamps have been kept together. Very too much bright is the too much heat is the maybe. But how the business will be there? Each one will be, and everyone have to come to this area, but not segregated. But you have to see the beauty of Tamil Nadu. Tamil Nadu beauty lies. It is not concentrating development in one location, concentrating development in major location. There are some locations I observed. Dharmapuri, Ramanpura. When I went, I felt why there is no development in this area. What is the reason? But because it is not the government made development, individual people, because of their education and the DNA, they had a focus on the development very nicely. That is the beauty of Tamil Nadu. Salem, industrial belt. Coimbatore, industrial belt. Trichy, industrial belt. And Tirupur, industrial belt. Chennai, IT belt. Like they made it. But if other neighboring state, that is not the. Now Andhra Pradesh is doing. This is for Google. This is for this is it. They are
Your
doing
voice
it.
is not audible, sir.
Voice is not audible. It is either muted. Hello, is it not audible?
Audible, sir.
Our Somasundram audible இல்லைன்னு தெரியலையே. Somasundram audibleன்றாங்க. நீங்க செக் பண்ணி பாருங்க உங்களோடது. So the development of cognitive and psych learning outcome is not there. And this is the area which also discuss about teacher and institutional autonomy. Because chapter number 13, chapter number 15 talks about teacher development. The teachers are the main aim for the development because they are the game changer of the system. If accreditation, when we go accreditation also, we give maximum weightage to the teacher, 200 mark, 220 mark. So beauty is teacher. And inadequate mechanism for career management, progression of faculty and institutional leaders. Lack of research, transparent, competitive, peer-reviewed research funding across disciplines. Suboptimal governance and leadership of higher education institution. Large affiliating university system with low quality, low standard higher undergraduate education. Nowadays, everyone is telling they are BE, but they don't know anything related to the fundamentals. That is the reason dilution of a BE, opening of several colleges without, because our beauty is regulatory authority ensures whether you have a space. But quality assurance mechanism is very, very poor. If you see the government constituent colleges, no intake in several colleges. They are on the verge of closure because they had a regulatory system made them to open chair is there, table is there, but they never followed a quality assurance philosophy, which resulted in the closing of the system. And faculty recruitment. That is also important because faculty are the backbone of the system. If they are being weak, recruited in a wrong manner, in a not consciously recruited, then the system get collapsed. That is the beauty. That is a beauty we can observe. So as I told you, NEP has a 4-part. First part, the school education, chapter number 1 to 8. Then comes higher education, chapter number 9 to 19. Then other key area of focus 20 to 24. And chapter number 4 is making it happen 25, 26, 27. What today's focus is on higher education. But you have to remember the purpose of national education policy is to create equitable and vibrant knowledge society, thereby providing high quality education to all, which in turn creates a Viksit Bharat. And not only that, they also promote sense of responsibility, fundamental rights, duties, and constitutional values, so that everyone will be aware of the role and responsible in changing the world. And then comes insisting value, skills, disposition that supports responsible commitment to human rights, sustainable development, living and global, thereby turning into true global citizen. So first principle of NEP 2020, respect for diversity and local context. Even when they brought Indian knowledge system, what they made, they asked us to customize the case studies, the example which are relevant to that location. If I talks about something which is not seen by my student, which is not easy for him to connect it. For example, you see the companies from Western culture, when they entered into the market, the first thing they focused on Indian context. இப்ப நாகர்கோவில் பக்கம்லாம் போனீங்கன்னா நிறைய பேர் வந்து எல்லா மதத்தினரும் கொண்டாடுவாங்க கார்த்திகை தீபம் எல்லாமே because now they started because that Indian context is local context is needed to penetrate into anything. Respect for diversity and local context. Indian knowledge system. If I talk about any case studies which is no way connected to Tamil Nadu, then my students will find it difficult to comprehend. So at the same time, I need to respect there is a diversity exists. This has to be brought in terms of curriculum, in pedagogy, and it also need to be focused on this one. It also need to be focused on the other key areas. It also need to be focused on the pedagogy and policy. That is the beauty of it. So you have to remember, it is not only focused on the one aspect, it has to be focused on all aspects. So respect for diversity, curriculum, pedagogy, and policy. Then comes equity and inclusion, which are the cornerstone of education. Inclusion, equity, and input. So don't brand the students, give them a scope, include from all segments. Because what happened each chapter I have a lecture, 90 minutes in lectures. That inclusion, equity, and inclusion chapter, I focus that AICT has brought 21 days induction program. Why they brought? To make inclusion among the students. Otherwise, if you're not bringing inclusion among the students will go by layer. He came because he came under sports quota. That's the reason he came. That culture will disturb. The purpose of this will get destroyed because of the system. Equity and inclusion. Everyone has to work together. Respect them. That is what important. And 21 days when they merge without the studies, they are not going to brand or rank based on the studies. They are going to get branded based on the activities and culture and ranks. That will give a more important. Okay, he may be all rounder. That is what the need of them. You remember, doesn't need to be you have to go score 100 mark. Even with 45 mark, you can do wonders. That is also beauty. So equity and inclusion, community participation, encouragement and facilitation of philanthropy. Unnat Bharat Abhiyan, the government of India. These are all principles of NEP 2020. Previously, it was the community development through polytechnic scheme. So, any community, through only education, you can transform the community. And you have to make it a community to participate. Without involving them, if you try to dictate it, it will not work out. There is a University of Texas, as Austin has studied some case study at Mexico. Even in India, when they after a Bhuj earthquake, when they constructed the building, without taking into account of the stakeholders, how the building occupancy become less. Valmiki Ambedkar Awas Yojana in Srirangam, I went for an inspection long back 2013-12. The occupancy was less. The reason is without involving the stakeholders, if you do it, it will not get success. Community participation, whereby the philanthropies like Infi Springboard. So there are philanthropies are getting into picture. They want to strengthen it, private and community participation. Then comes use of technology, which is very, very important. Through technology, you can avoid the barriers. It is not only for Divyang students, for everyone. Sometimes I might be a learner who takes more time to comprehend the thing. I cannot keep asking my teacher to do it, but I can learn from the technology. I can learn, I can listen from it, I can repeat second time, third time, fourth time, fifth time. Eventually, I can obtain the knowledge very easily, very casually. I can obtain the knowledge. That is what the purpose. Emphasis conceptual learning because the current student they are focusing more on the this thing. rather than rote learning, learn from exams. You remember, learning for exams. Because they are only learning for exams and rote learning. That is a big problem. Why they are doing what for, and our teaching is also structured accordingly. It is not focusing on the complete development or situational, because which I observed in US and Germany, I observed where the content is good, the focus is only making the content low. It is not towards the mark. Here we are focus is towards the mark. Unique capabilities, recognizing, identifying them in each student. Recognizing them, identifying them each student. Each student is having unique. That is what I am going to tell in the next few slides. I will be showing you. Critical thinking and creativity. As I told you, previously it was not exclusive subjects. Now it is needed because of the development. Because my grandfather, my mother might have remembered around 50 phone numbers without looking into the diary, landline number. But I might remember only 10. But the current generation, even they're not remembering their own number. That is the beauty. So the pattern have changed, learning pattern have changed, comprehending pattern have changed, grasping pattern have changed. Holistically, everything have changed. So the critical thinking and creativity also becomes like a subject which has to be infused. ஒழுக்கம் என்பது சொல்லிக் கொடுக்க வேண்டியதாயிடுச்சு. That is what it is needed. The words, even adult, they are not keeping up the words. Remember, நீங்க அதை பண்ணல, அதனால தான் இதை பண்ணலன்னு சம்டைம்ஸ் டென்ஷன் நம்ம பண்ணதுக்கு அக்னாலஜ்மெண்ட் கிடையாது, பண்ணாதது. Then they didn't call. That is a beauty which you have to remember. Continuous review based on sustained research and regular assessment by education. So when I've cleaned the mirror today, doesn't mean that I don't need to clean the mirror. Every day, frequently I have to clean, because there is a possibility of getting dust. That is that, because everywhere, every system. So continuous review has to be there to check are we going on a right direction or not. Regular assessment is also needed. So these are the 8 key principles of NEP which generally we focus. Then now comes the next one, higher education. If you see the first chapter number 9, the beauty of chapter number 9 is quality universities and colleges. One of the very, very smallest chapter, 9.4 வரைக்கும் தான் இருக்கும். 9.3, 9.2, in depth they will discuss about what are the challenges which I have told, fragmentation, silo approach, everything they focus. But in the 9.3, they talks about what are the ways. They never talks about the problem. They also talks about key changes which you have to make it in the policy. Light but tight. You remember, very, very important. ODL, very, very important. So different local languages in Indian languages, very, very important. Faculty and institutional autonomy, which is very, very important. And they talked about establishment of National Research Foundation. So in the various aspects around 9 they might have discussed what all the steps should be taken to get implemented. That is what the quality universities and colleges, a new forward-looking vision for. Up a new quality university, so can we close it? No. That is what the policy clearly talks about, the chapter number 10. To have a quality universities and colleges, then you have to focus on institutional restructuring and consolidation. You remember the chapter number 10 is very, very important chapter, because chapter number 9 pathina oru chinna chapter, 12 kuda chinna chapter, but 10 வந்து ரொம்ப பெரிய chapter, which is a 14 subdivisions are there, which clearly tells this chapter we want to get rid of certain items, especially the term university. It is very confusion, and there are separate nomenclature: deemed to be university, affiliating university, affiliating technical university, unitary type university. All should be replaced with the term university. Upper university na yen. They told it two different: research intensive university, academic intensive university. Research intensive university, they are focusing on the more focuses on a research, and they give equal emphasis on teaching and research, but more focuses on the research. So that is research intensive university. Whereas teaching intensive university, where the significant emphasis on a teaching, but still they will be continuing some research in terms of capstone projects, everything. That is academic intensive university. So these are the way which the beauty you have to appreciate where the degree awarding college, autonomous degree awarding colleges, and then comes the other items which I would have told, which could be used for learning. So the chapter number 10 talks about restructure the existing institution and consolidate them. All smaller institutions, group it together, make it into big, make it into knowledge hub, make minimum of 3,000 students or more students need to be made. That is the one condition they are keeping. So they are telling we should have aim to have 3,000 or more students. That is the one which they want to focus. So why they are focusing? They want to make it similar to our old university, Nalanda, Tashkila, and other colleges like Vallabhai, Vikramashila. So all those colleges like that, we have to focus, which has to be a major focus, which has to be a major focus, and eventually, which is also discussing the creation of other items. So that is. So then comes towards more holistic and multidisciplinary education. This is also very, very important because Aya Kalagal 64 we talks about. Even in the Bahubali movie, if you see the junior Bahubali may not be doing things properly, then Kattappa will teach him. Your father used to do all those things. Because the movie itself, they would have told two generations. Now the generation have changed, how the generation is not aware of it. So the 64, this thing. In addition to the normal education professional field, and scientific field such as chemistry or mathematics or vocational as such as carpentry or any other goldsmith, anything you can keep it. And they focused on this thing, which is what Western world is liberal arts they talk. So the Banabhatta's Kadambari, 64 form of arts, how it has to be incorporated, to science, technology, engineering, and management. That is what we call the STEM education, which provides a holistic education to the individuals. Holistic education to the individuals, where the government focus on 3-year degree, 4-year degree, multiple entry, multiple exit, multidisciplinary approach, holistic approach, where the literature also you can take it, how the minus has to be there. Everything they have given in a broad spectrum, but it has to be implemented in toto. Then only the beauty of the implementation could be encouraged or encashed. That is what the beauty. So this chapter number 11 talks about multidisciplinary education research university. What they call it as a MERU, 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 they call it as, which is the multi-level higher education institution. So that is what the beauty. Then okay, quality ஆக்கணும், இருக்கிறத ரீஸ்ட்ரக்சர் பண்ணணும் to provide more holistic. But இதெல்லாம் இருந்தாலும் success comes by optimal learning environment support of students, where the choice-based credit system, pedagogical system, curriculum, continuous assessment, online degree program, where they can do second degree, high quality pedagogy, all those things are discussed in detail in the chapter number 11, 12, sorry. And they also talks about financial aspect support for students. So a special scholarship, national scholarship scheme. So how the campus has to be there, what are the different clubs has to be there, sports club, cultural club, art club, eco club, activity club, community club, all the clubs, how it has to be there, how internalization has to be made, how the foreign students has to be there, brought in, how the ODL need to be infused. So how we have to become a Viswa Guru. These are all discussed in the chapter number 12. Viswa Guru chapter number 12. So where they are focusing on optimal learning environment and support for the students. Then comes very, very important chapter, the chapter which focus on the teacher welfare. That is motivated and energized and capable faculty member. This is what they told, the faculty or the crux or backbone. So yes, very, very important. The faculty need to get trained appropriately. Appropriately, they have to get trained. That is what the need of the hour. If the faculties are not being trained, rather than a symbiotic relationship, they should not become a parasitic relationship to the any education institution. So the motivation capable faculty member, how the tenure track need to be there, how the mentoring has to be. The national mission on mentoring is also discussed. One of the very important aspect which is discussed in the chapter number 13 is institutional development plan. Now, criteria number 1 நடத்தும்போது NBA I used to talk about strategic development plan. From a strategic development plan, it is nothing but institution development plan need to be prepared. And from the institution development plan, department development plan need to be there. Institution development plan, there are 5 segments. Other one such segment is the faculty. That is what this chapter number, this thing. Then comes very, very small and unique chapter, equity and inclusion in higher education. It has only 4 parts. But beauty of this chapter is, it talks about not only what it has to be there, it lists 2 important aspects in 14th chapter. It talks about what are the steps to be taken by the government. Compulsory the step நீங்க எடுத்தே ஆகணும். What are the steps to be taken by the higher education institutions? Very clearly gives the given by this chapter. It keeps a target for higher gross enrollment ratio, 50%, 2035. How the fund has to be earmarked for educational purpose. Because of a fund earmark பண்ணலனா, then you cannot make the wonderful. That is what needed. And it talks about revenue generation. It talks about SEDGs, special economic education zone. It talks about how the special economic zones become a cluster. High quality, bilingually, how we have to focus on it. So, what are the ways which you can participate? These are the ways which the government should take care of it. And what are the ways higher education should take? Bridge course, curriculum should be more inclusive. Employability potential should be there. Opportunity, we have to make the opportunity for a cost and fee for pursuing financial assistance and scholarships. And we have to focus degree program on Indian languages and bilingually. Develop SDGs based on this course. So these are the focus on chapter number 14, equity and inclusion. Then comes one more chapter, it is known as a teacher education. In this teacher education, predominantly it is focused on Burma's Commission's report 2012, where B.Ed teachers were there, which was for school education. In higher education system, 2020, January 12th, they launched a national mission on National Initiative of Technical Teacher Training, where the individual faculty members who are working in engineering colleges have to follow this in toto. And similarly, we have to find the same thing concept has been integrated for the following in the other aspects. So the teacher education plays an important role where they brought integrated B.Ed program, where their main focus is to integrity restore, credibility establishing. And whenever the teacher are working with efficacy, acknowledge them and honor them and give appreciation to them and motivate to them. That is what very, very important. They are the high value of a teacher education system. That is what which you have to remember in detail. You have to remember reimagining vocational education, because now national skill qualification framework, national higher education qualification become both have been merged together. So in that situation, how the vocational education need to be there. Suppose multiple entry, multiple exit, if it is there, how we can promote it and how we can operate it. That is what the beauty which you have to see. Reimagining vocational education. Catalyzing forming of a national research foundation, Anusandhan Research Foundation, transforming the regulatory system of higher education. As you all aware, AICT and UGC has been, they are trying to build, bill is going to be passed, and it has been brought to the joint committee. That is the beauty of it. So transforming the regulatory. Last one is effective governance and leadership for the higher education institution. So these are the chapters from chapter number 9 up to chapter number 19. 11 chapters had been focused on the chapter number 4, that is a engineering, that is the higher education. Then comes the chapters, as I told you, which is the how it was operated, and then finally this and making it happen. So 21st chapter is nothing but a promotion of this one, very clear that this one is what is it? Professional education, adult education, that is chapter number 20, professional. 21 is this, 22 is promotion of Indian language, arts and culture, technology use and integration. Then 24th comes the online ODL degree. So the part 2 is only to making it happen. That is also the focus which you have to remember. So then what are the situation what we face? These 7 problems we'll discuss, and these 7 problems, what are the solutions we'll discuss. First one is a rote learning. As I told you, in the chapter number 9 itself, we have told the rote learning is going to make a problem. The key principles of NEP 2020 also, the first thing I told is rote learning. Rote learning has to be completely eradicated, or completely it has to be. That is the first. Second one is the evaluation system. Third one is the equal respect of all subjects. Fourth aspect is better training of educators. Fifth aspect is introduction to technology. Sixth aspect is personalized education. Seventh aspect is teach them the purpose of education. Teach them the purpose of education. Rote learning. Currently the students are doing a rote learning. That is it. One of the college I went, Coimbatore, they told they want to implement CDAO technique because one college already implemented CDAO. They are very famous. Good, good. Because it's a Western philosophy. I'm not against any Western philosophy. You have to remember conceive, design, implement, operate. Sometimes to conceive, I need to have awareness. Unless awareness is not there, how I can the position to conceive? First, I need to aware. No, this is what I can do based on this thing. If I'm not aware of it, how I can conceive the things? It's very difficult. So in that situation, you have to remember the rote learning creates a big problem and big issue. So big problem and big issue. It is the so evaluation system. So evaluation system, what it is there? And equal respect evaluation system. Okay. Evaluation system NEP 2020 talks about the formation of parak. What is parak is that is a complete holistic development, how we have to operate it, how we have to do it, and what is the need of it and why we have to operate it. That is what the beauty of it. So when it talks about NEP 2020, so you have to remember uh, what are the aspects which you have to focus it. That is the beauty. And what are the ways which we can make into happen. That is a aspect because they focus on formative assessment predominantly rather than the summative assessment. Formative assessment rather than the summative assessment, it has been focused. And the beauty of it also we have to observe it. So what are the aspects which we are clearly having an idea? Because the summative assessment is not going to play an important role. Formative aspects only going to play an important role. So that aspect has to be kept into consideration and it has to be focused. then only the best will be evaluated. So equal respect for all the subjects, art, science, and commerce. So how it has to be operated, and what are the ways and means which you have to operate. Because there is no respect for the teachers. That is the, for example, I have seen in engineering colleges, the engineers department will look ahead when compared to the arts and science department. When compared to the arts and science department, a college, if you go, the science department will be very strong, and they will not focus on the other aspects. So this is the beauty. Always it plans accordingly, and it helps them. And it goes into the different direction. So how we have to focus on it? Art, science, and commerce, and how it be operated. Equal respect to all the subjects. Equal respect to all the subjects which you have to focus on it. Then comes better training of educators. That is the reason to promote to the equal respect for all subjects. Holistic and multidisciplinary aspect has been focused on the chapter number 11 and 12. Better training of educators. How we have to educators need to be trained. What are the ways and means the educators need to be trained, and how it has to be operated. That you have to remember. How we have to operate it. What are the ways and means that educators need to be trained. And introduction of a technology and the technology has been there, and it has to be operated appropriately, and it has to be done in a different manner. So the technology usage is very, very focused. Exclusive chapter on chapter number 23, how the technology need to be incorporated, what are the ways and means technology need to be used, and what are the ways and means the technology need to be uh, uh, given to the students. That what the focus it gives, a very, very important aspect. And personalized education, technology in education basically focus not only this thing, it also gives a personalized education. How it has to be personalized, what are the needs to get personalized, and it's very, very important. What are the ways and means which you have to operate upon it? Personalized education. That is what the beauty of it, and that's beauty you have to appreciate it and learn it in a clear manner. So teach them the purpose of education. The students need to learn the purpose of education, educate to remove from the darkness, to unfold the truth, unfold the creativity, unfold the problem solving aspects, which has to be focused and which has to be operated in a better manner and a different manner. So in that situation, we have to remember what are the ways and means which you have to operate it, that is becomes a culture. All holistic learning, scientific temper, evidence-based thinking, and aesthetics and art, which are very, very important, which are our need for the education system. How we have to promote the holistic learning, how we have to provide the scientific temper, and how we have to provide the evidence-based thinking. And complete learning has to be focused on the NEP 2020. So each chapter unfolds predominantly on the light and tight manner. And they are talking in terms of equality university, the predominant focus is the medium of instruction or program has to be in a local and Indian languages. Local and Indian languages. It has to be there. It has to be there, and it has to be promoted appropriately. It has to be there. It has to be promoted appropriately. And online learning, online distant learning, how we have to operate it, how we have to operate it, how we have to give a importance to it. And tenets of the policy: flexibility, equal promotion of arts, science, physical education, other extracurricular activities, multidisciplinary approach, cultivating life skills like cooperation, teamwork, empathy, regular formative assessment rather than the summative assessment need to be given more weightage and importance. To develop the good human being, rational thought, what all the things, that is the purpose of this policy. To provide courage and resilience. to promote scientific temper and creative imagination, to thereby promoting ethical moving and the values. These are the things which you have to operate it and which you have to focus on the different directions. So there are the key changes in the current education system has been focused. If you follow the NEP 2020 in toto, if you follow NEP 2020 in toto, we can stand apart. We can stand apart. Each chapters, each line, it focuses on a different direction. It focuses on a different direction. For example, internalization, capable faculty member, equity and inclusion, teacher education, reimagining vocational education, and what are the aspects? Transforming the regulatory system from higher education. So it is impossible to redesign students to fit into a system, but we can redesign a system for the students. We can redesign the system for the students. So how we can redesign? If you understand the nuances of National Education Policy 2020 in depth. So this comes only based on debate and deliberation, sir. It is not a document which has to be dealt. It's like a rule book. You cannot follow it. It is the philosophy how you could decode it, how you could connect it. As I told you, the concept of universities, different types of universities, it is discussed in the chapter number 10. The concept of the concept of holistic, multidisciplinary education, this is focused on the chapter number 11 and 12. And how the choice-based credit system, how the teacher education has to be there, how the national mission on mentoring has to be there. It has to be focused. So each items we have to focus in a different direction and we have to operate it in a different aspects. If you follow these aspects in detail, so there will not be any problem and there will not be any issue. There will not be any nuances. That is the beauty of it. So this is the beauty which you have to operate it and which you have to look into it. When we operate it and look into it, so this is the thing which you have to focus on. So when we focus appropriately, the system is better and the system is clear. So that is it. So to develop the Viksit Bharat, what is the next step for it? Understand the nuances of the chapters. Chapter number 20 talks about professional education. How the professional education need to be acknowledged. Now comes the beauty. They are linking the professional education with APAR ID. When they link with APAR ID, how you have to connect it, how you have to operate it, how we have to make it into a degree. That is what they are. So each learning need to be creditized. Whenever it has to be creditized, it has to be assessed. That is the important aspect which you have to remember. So what are the aspects which you have to take into consideration? That is what the important item which you should remember, which you should operate upon it. So when we operate appropriately, then comes the beauty in a clear manner. Clear manner. What is the clear manner? So how to do it? So we have to think big. Is it a right or wrong? Because some, as I told you, 42nd Amendment in the year 1976 made the education into a concurrent list. When we made the education into concurrent list, it is depending upon the state and center, the following of NEP becomes an issue. Some state immediately they bring out a state educational policy. But the state education policy should get aligned with the industrial education policy, institutional development plan. That is what they important. So it's a question of right or wrong. It's a question of our future. It's a question of our future, how it has to be operated. And my question to decision maker, whether we can win the race, I am sure we are slow, but we are steady. We are slow, but we are steady. And how to operate it. If you have any doubts or any questions, any comments, you can next 10 minutes I will be available. We can deliberate on each chapter in toto. I can do it because That will give more clarity to you and more clarity to everyone. No, because for example, I have, for example, 6th, 11th chapter, holistic. We used to discuss about Bana Bhatta. The 64 forms of art, Geeta Vidya, Vaidya Vidya, Nirtya Vidya, Natya Vidya, Alekya Vidya. So all those concepts we used to discuss, and where the 64 forms of art has been provided in the form of a diagram. So which has been given. And then comes what are the, how it has been grouped in the current education. Music, arts, painting, liberal. Math and astronomy, scientific, weaving, carpentry, vocational, medicine, engineering, professional, debate and communication, soft skill. 64 colors have been grouped. So how the creativity thinks and how it works out. So multiple degrees. So each part we can couple in a different manner. For example, social inclusion. In this chapter, we focus on this aspect, diversity and inclusion education, how others could be joined. So that is also important. Diversity. Giving a same chair is not important. Diversity means race, ethnicity, gender, ages, socioeconomic status, cultural, everything. So the diversity matters a lot. That is what. So it is a 723 in 2014, 120, 139. So increase is there. So increase in higher education institutions are there. So today India is the world largest, second largest higher education. So in that situation, we have to remember gross enrollment ratio 50, what we call it as a universalization of education. Elite only previous education was there from massification. This is called what we call Martin Trost formula. So government of India wants to make now universalization, which is covered in equity. So in this chapter, what we focus, what is the concept of equity? Equity, because they're telling about different aspect also. So social diamond culture, academic domain, everything. And the syllabus has to be restructured. You remember, inclusive campus, SCSTs. What are the steps to be taken by the government? What are the steps to be taken by the higher education institution? Very clearly, it has been given. And how it has to be operated. The space, RAM, everything is in NEP 2020. Providing a RAM, it is chapter number 12, inclusion, diversity, how it has to be operated. So, the chapters are very clearly given, sir, and it has to be decoded in a different direction. So next 10 minutes, if you have any doubts or any questions or if you need any clarity, you can just let me know. We can discuss and deliberate. Over to the participants, please.
Sir, good afternoon, sir.
Yes, sir.
So it was a very good session from you, and thanks for that, sir.
Thank you.
I have a simple question, sir. I'm working for engineering college,
Okay.
and you've been mentioning about the B.Ed programs and other programs to be integrated along with the curriculum or along with the faculty development programs. And I was also reading through the NEP, and I found that by 2030, they are expecting all the colleges and universities to be multidisciplinary, number one.
Yes, sir.
As colleges and universities all move towards becoming multidisciplinary, they will also aim to house outstanding educational departments that offer B.Ed and M.Ed.
Yes, sir.
So this is what I can understand from the reading of NEP 2020 documents, sir.
Yes, sir.
But what I basically feel from my experience and from my experience visiting other engineering college as well is that the teachers are basically subject matter experts, but they're not pedagogical experts. And as NEP rightly puts it, that they need to be educated in pedagogy as well, and that can be initiated through B.Ed and M.Ed program. Where in the educational system do you think this is going to happen between now and 2030, sir? Because I don't see any of the engineering colleges having initiated this type of B.Ed or M.Ed into their faculty development or whatever. So as an expert from NITTR, what exactly you think and how we can implement in the engineering college, sir?
Okay. Okay,
I'm sorry
fantastic.
for
No. I'll tell you. Very nicely, sir has asked based on the NEP 2020. You're talking about B.Ed, M.Ed, how it could be made, sir. Is it possible for the engineering college faculty members? You have to remember very nicely, yes, framed this question. Is it for the engineering college faculty members? That was a good program, yes question. You have to remember Verma Commission, Justice Verma has given a judgment based on the Verma Commission only 2012. They are focusing integrated BA Tech, and you might have seen several schools and several election portfolios also. We remove this score, that score, all those scores have been there. The regulatory system focused on teacher education, integrating the B.Ed program for higher education institution. For example, NITs and IITs, they have started. Already there is a program scheme is available where they are doing integrated B.Ed programs are available. Is it possible in higher education system? It's possible, but we don't have a specific undergraduate program in the institution like BSc Science and BSc Maths, BSc Physics. We don't offer in a higher education system. Then what will happen to engineering college faculty members? Are they don't want to get empowered on the pedagogy aspects because they are the subject matter experts. In the year 2019, AICT has brought out a guideline known as National Initiative for Technical Teacher Education. It is a prelude of this NEP. Based on this NEP only we were working on it. At the time NEP was not launched, but the commission wants to look into everything. It for all the branches, all disciplines. So for engineering, there is a catastrophic place. So they want to introduce this part, and they introduced in 2019. And 2020, January 12th, Swami Vivekananda's birthday, they launched the scheme with a portal. The student faculty members have been asked to complete 8 modules related to pedagogy. What was this? Because B.Ed and M.Ed has been abolished for engineering domain. It is only for arts and science and school education, predominantly school education. They don't want to once again open the Pandora box. So they brought a scheme known as National Initiative for Technical Teacher Training. It is a mandatory. It has been implemented in toto in all government colleges. It is implemented in toto. They have implemented in toto. So what way we have to do it? What way we have to do it? And very clearly it has been given. It has been very clearly it has been given. What are the ways and means it has to be done? What are the ways and means it could be done? So if you observe the beauty, NIEEE scheme, the faculty who are having less than 5 years of teaching experience, as on the Gazette notification is there, particular date, all the engineering college faculty members have to mandatorily complete these 8 modules. They have to secure. One beauty what they brought is they have to work with a mentor for 1 semester. The mentor, there is a rubrics have been well established. It has been available in the portal. It is online mentoring scheme. Online mentoring has to evaluate the things in online, and he has to, because if I am a college working in SAR college, PMC Tech, the faculty from that tech college only I can mentor. I cannot mentor the neighboring college. That they made it very clear, because it should not create a dispute, because the mentor is not going to get any honorarium for it. Mentoring, National Mission of Mentoring is a service oriented. In that situation, how we have to operate it? How we have to operate? That is what the question which they made it. In that situation, you have to remember the National Mission on Mentoring, the predominant was focusing towards the 6 months mentoring. After mentoring, the faculty members from engineering college has to mandatorily undergo a 4 weeks industrial training program. This is a part of a program similar to B.Ed has been brought to engineering college faculty members. It is written and Gazette notification came. When a Gazette notification came, it has been for all government colleges they are following. And it is not only from the assistant professor cadre, even associate professor cadre and professor cadre it is there. But associate professor cadre and professor cadre, they removed the industrial training. They made some other courses related to advanced in the level, advanced in the leadership program, academic leadership program, strategic management, all those things they brought. The main purpose, what for they brought is, they brought it to solve this issue, to solve the 15th chapter, because they are subject matter experts. They need to be expert in the pedagogy. That is the beauty of it, which they have given. So nothing more than that. So that is the beauty of it, and it has been very clearly given in the policy, and gazette notification is also available. It is available. For medical fraternity, what we did, I will tell you. Vardhaman Mahavir Medical College, Sarfadagal, around 200 doctors we have trained them, because they don't want to teach the pedagogy aspect. We want to teach them online pedagogy, how we have to handle it, how the reflection learning has to be there, how the case studies has to be made. In Mangalore Medical College, where we have trained, how for a forensic medical college, how the case study based this thing has to be made. For dental, more than 300 dental doctors we have trained. It's a Krishna Institute, Maharashtra, Karkada, all those regions we have trained online. The beauty is, medical it is not mandatory, but whereas arts and science and engineering, they made it mandatory, and it has been connected with a 15th chapter based on the Verma Sir Commission. It is for school education. Eventually, it has been extended to the higher education also. Is it okay, sir? You have any doubt?
To be honest, I am partially convinced. Because my question also asked on how we can house outstanding educational department like MEd and BEd in the engineering college, because I can ask an IEEER or I can ask an IT expert to come here and teach some pedagogical lessons or training to be offered to our faculty. But how to house outstanding educational department within the campus?
There is a regulatory
Is
mechanism is there, sir. There is a regulatory agency is there. There is a formal procedure is there, how to start a teacher education programs. The same route it has to be followed. For example, BEd and integrated BEd, there is an exclusive mechanism, but at present they are keeping some condition. NBA this much and integrated BEd program. That is what the government portal is there. There you have to get into national integrated teacher National Council of Teacher Education, ITEP.
Thank you, sir. Thank you, sir.
That is the region integrated 4-year integrated teacher education program. As per chapter number 15, I can show you the screen. They are the agency who are working on it. We have to contact them. I will screen the screen. I will share the screen.
National Council for Teacher Education.
Integrated Teacher Education Program. So you can apply online and you can see. But there are some this thing at present they are open only for the CFTAs. They are never open. They open only for INIs. So after INI, they have to look into the document and how the system, everything they've streamlined, how the curriculum has to be there, common entrance examination. No, it has been made and
Okay.
Dear participants, is there anybody having doubt regarding NEP 2020? Good afternoon to all. Thank you, sir, for your highly insightful and inspiring session on National Education Policy 2020, sir. Your valuable thoughts on transforming education through innovation, quality, skill development, and outcome-based learning have given us a deeper understanding of the vision and impact of National Education Policy 2020, sir. The practical insights and experience you shared from your vast academic and professional journey were truly enlightening and motivating for all of us, sir. We sincerely appreciate the time and effort you have taken to interact with us and share your expertise, sir. On behalf of the management, faculty members, organizers, and participants, I extend our heartfelt gratitude to Dr. G. Janathan, sir, for delivering such a wonderful session. Thank you once again, sir. We are truly honored by your presence. And thank you, participants. Now, participants are requested to fill the utterance and feedback link immediately. Now let's go for lunch. Participants are requested to join back at 2 p.m. for the valedictory function. Thank you all. Thank you so much.
Thank you.
Thank you, sir.
Good afternoon. Vidya ma'am, good afternoon.
Good afternoon, Shri.
Afternoon, ma'am. Thank you so much. Thank you. Ma'am, we'll wait for a couple of minutes so
Sure.
that Professor Vijay sir will join the validity
Yeah,
session.
sure. Okay.
Good afternoon, sir. Professor Vijay sir. Good afternoon.
Good afternoon, madam.
Good afternoon, sir.
Good afternoon. Yeah.
Thank
It's
you
my
so
pleasure
much.
to be with you.
Thank you so much, sir.
Yeah.
Thank you.
Thank you.
Good afternoon, Vijay, sir.
Okay, no problem, madam. You carry on. No problem. I'll wait. Yeah.
Just couple of minutes, sir.
Yeah, no problem. Okay.
Good afternoon to one and all. It is my privilege and honor to welcome you all to the validatory function of the ISTE-BNY Knowledge Enhancement Program, the 6-day faculty development program on quantum assisted federated learning for secure distributed intelligence. On behalf of the Department of Information Technology, RMK Engineering College, I extend a warm welcome to all the guests of honors, faculty members, participants, and guests gathered here today. Now it is my proud privilege to welcome our esteemed dignitary. I extend a hearty welcome to Dr. M. Shaileen Bono, Professor and Head of the Department, Information Technology, RMK Engineering College. Madam, your dedicated efforts and support have played an important role in the successful organization of this faculty development program. We are delighted to have you with us. May I now request Madam to kindly introduce our distinguished guests to the gathering.
Thank you. On behalf of the management, faculty, and organizing team, I extend a warm and hearty welcome to everyone present here today. It's my privilege to welcome the chief guest of today's function, Professor Vijay D. Vaidya sir, who is a coordinator of ISTE-BNY program. I also welcome our guest of honor, Dr. Vidya Durai. Madam is director in BNY. A warm welcome to both dignitaries. And I welcome all the participants who have actively participated in this ISTE-BNY Knowledge Enhancement Program, a 6-day faculty development program on quantum-assisted federated learning for secure distributed intelligence. Thank you all participants for your enthusiastic interaction with the resource persons. We had very exhaustive sessions. The resource persons from various organizations, they deliver the sessions in a very fruitful way. And I would like to see the participants interacting with them, asking more number of queries to the resource persons. And it's a very kind of a special occasion for us to host this kind of ISTE-FDP program on this emerging technology like quantum computing. And most probably, like we will like to have such a kind of a program in collaboration with ISTE and BNY in future upcoming years too. And to be more specific, I would like to thank Professor Vijay sir for giving us a grant of 1.25 lakh for organizing this faculty development program. This indeed is a very great opportunity for us to enhance the skill sets of the participants as well the faculty members of RMK Engineering College. Now let me brief about the profile of our guest of honor today, Dr. Vidya Durai. She's director in BNY. Dr. Vidya Durai has an experienced blend of academics, research, philanthropy, and IT leadership spanning 40 years. She was a faculty at Anna University, currently managing the Global Impact Citizenship function for BNY India. She has spent 24 years with the organization in various strategic capacities. Specialist in electronics and communication engineering, Dr. Vidya Durai's research focuses on parallel algorithms and parallel reconfigurable architectures for image processing. Her career is defined by a unique ability to bridge the gap between technical innovation and social good. She has spearheaded research projects for NGOs and major institutions, including the Ministry of Electronics and Information Technology, IIT Madras, and CDAC. Beyond her corporate and academic roles, Dr. Vidya Durai is a dedicated advocate for environmental and social sustainability. She is a member of the Research Council, IIIT-DM, Syllabus Committee member at Anna University, and she currently chairs the CSR Committee of the Madras Chamber of Commerce and Industry and serves as a trustee for the G81 Foundation and the Rajalakshmi Srinivasan Memorial Foundation. She holds a PhD in Electronics and Communication Engineering and is a graduate from the Securities Industry Institute, the Wharton School, UPenn. Ma'am, may I now request you to deliver the special address, please, ma'am.
Thank you, Shireen, for a beautiful introduction.
Thank you, ma'am.
Good afternoon, everyone. So it gives me a lot of happiness to be back in an environment of learning and intellectual rigor as being part of an educational institution like RMK. As I look around this room, I am reminded of my own beginnings in the early 1980s as a lecturer at Anna University. Only the tools have changed. Yes, the tools have changed. We were concentrating on microprocessors, and now from early microprocessors to the quantum frontiers that you have discussed this week, the core mission, there have been changes, but the core mission of a faculty member, I would say, remains the same. Right? All of us exist to be the architect of the next generation's technical consciousness. So why this STP matters? The topic of this program, quantum assisted federated learning for secure devices. Actually, it's very interesting. I think only Shireen can come up with such topics. It's not just an academic exercise. We are living in an era where data is our most valuable asset. While data is our most valuable asset, privacy is our most fragile right. While data is the asset, we have a right to privacy. So this program, quantum assisted federated learning for secure devices, actually combines the two. While using the data that's available plenty, in abundance, we also are looking at privacy and with the latest technology, which is quantum computing. So if we had, I think I don't have to talk about this, but still just for completeness sake, we know that traditional federated learning was a massive leap forward, allowing us to train models without moving sensitive data. But as we look towards the horizon of quantum computing, see, with quantum computing, we have the power, right? We face a paradox. We have the power to process, but also the malicious applications also have the power to process. So this is a paradox. While we go in leaps and bounds in terms of the technology, the malicious malicious users also are growing in leaps and bounds. So if when technology improves, when a technology gets enhanced, it's not only the good people that get access to this, but also the malicious people who get access to this. So while traditional federated learning took a massive leap with quantum computing, we also face a paradox, as I said, of the same quantum computing and the same technology that offers infinite processing power also threatens our current encryption standards. Because when we have processing power, what happens, the decryption also gets the same kind of processing power, and therefore we need to move towards more secure systems. So by exploring quantum assisted learning, I think uh, the space, the context of this program would be very clear now, that while we are using quantum computing for our federated learning models, we need to use quantum computing for securing our devices also. So we need to essentially learn how to build a fortress that is both intelligent as well as future proof. So I think in that context, this is a very, very beautiful program and very futuristic, combining these two aspects of computing. And congratulations to Shireen and the organizers and RMK. RMK has always been a forefronter in such initiatives. So congratulations to all of you and all the faculty members who have attended this program. And I hear from Shireen that you have been very interactive and with a lot of questions. That's really good. And I, apart from this, I just want to also reiterate one context. It's, I think, this year's International Women's Day theme is Give to Gain. While it is the International Women's Day theme, it actually suits all of us, the faculty members, the teachers, right? We give to gain. So earlier, actually, when I joined Anna University, I was very happy. It was a premier organization. Those days, very few colleges, and I got into the institute as a lecturer. And I was really very happy. I was very proud, and I thought that I was going to make the whole place great. And I have group of very smart minds, and I'm going to train them. So that was in my mind. I was a very proud person when I joined Anna University. But then within the year, I realized that I was not just giving, I was also receiving, because the questions, the thought process of my very smart, very intelligent students actually shaped me over many years. So that is how I also learned. While I see, if I have to teach in the class, then I have to go and learn, because what I studied became obsolete very soon, and I had to learn. And with the kind of students that I had to really slog. And I'll just give you one example. I was teaching digital logic and switching theory, and my treatment of the subject is very, very different. 60% I don't take attendance in my class. 60% anybody who studies well will be able to answer, and 20% some intelligent person will be able to answer. But the rest of the 20%, only those who attend my class will be able to answer. So if you don't attend my class, you will get only 80% maximum. But you will get 80% if you slog. But if you attend my class, that 100% is assured. So I take that as a pride moment, because I uh, believe in giving my best to the students. And as I said, I want to just recount one incident in a class. I was teaching digital logic and switching theory, and as I said, my treatment is very different with VLSI and all those things brought into the picture. And I gave a test. It was a 1 hour test, and the next day, the students, all of them, came back to me and said that it was a very long paper and they were not able to complete it within the hour. Then I took the chalk piece, went to the board, and completed the entire paper within 45 minutes, and told them that they were memorizing. I was not memorizing. I was just, I had not prepared myself for the test. So, this is the role of a teacher. See, you should be really very proficient in whatever subject we are dealing with. And in my role at BNY, and through my work with Madras Chamber and various other charitable organizations, I see real world demand for exactly what you have been studying. whether it is the financial system or healthcare accessibility, like in our case, or like we did uh, work with the Vision Companion mobile app for differently abled people. The world needs secure device attributed learning, and that's the need of the hour, whatever be the domain. The need of the hour is security and secure systems, and this is again, as I said, very important. And to the point of give to gain, I think I don't have to expand on that. All faculty members uh, gathered here, you know that if you give, you gain. How do you give? You learn and give, and that is how you gain. So in research, this means sharing insights, collaborative models, that is the give part, and to achieve more robust and secure collective intelligence, and that is the gain that we uh, get from this kind of exercise. And federated learning is a technical embodiment of actually this philosophy, give and gain. More amount of feedback, if you give, then more amount of feedback gets into the system and more intelligent the system becomes. So this give to gain, I feel that it's a very strong slogan for technology, as well as, I mean, AI technology, as well as our faculty members. And to all the participants here, esteemed faculty members, you are the bridge. The knowledge you have gained this week must be distilled to your students. And I urge you not to just teach these algorithms in isolation, teach them as the tools that will protect human privacy and enable global innovation. So, thank you so much, Shireen, for this opportunity. I really cherish this. Thank you.
Thank you, ma'am. Thank you so much. Thanks a lot for inspiring with your speech. So I think we faculty members, we have learned very good, inspiring quote from ma'am that we have to transform our students into greater heights. Thank you so much, ma'am, for being with us today. May I now request, yes, ma'am. May I now request our chief guest, Professor Vijay D. Vaidya sir, coordinator for ISTE-BNY program, Indian Society for Technical Education, to deliver the valedictory address. May I now give a brief profile about Professor Vijay sir. He is a coordinator for BNY, ISTE-BNY program. He was born in Kolhapur, Maharashtra. He has obtained his BTech degree in civil engineering from Karnataka Regional Engineering College, Surathkal, Karnataka, presently known as NIT Surathkal, in 1981. He worked in construction fields with Afcons, Mumbai, at different sites in Karnataka, AP, Goa, MP, etc., and also worked with a designer firm and did structural designing for different types of structures like residential, commercial, industrial, and public buildings and water supply schemes. He joined teaching field in 1985 as lecturer in civil engineering department in Government Polytechnic. Since then, he has worked in different capacities in Government of Maharashtra. It includes lecturer in civil engineering, head of civil engineering, training and placement officer, vice principal, and principal. He has worked in administration in Directorate of Technical Education, Mumbai, as Assistant Director, worked as Deputy Secretary in Maharashtra State Board of Technical Education, Mumbai, which deals with the diploma education in Maharashtra. He was handling curriculum development cell in MSBTE. He is having the following achievements to his credit. During field work at construction site, completed time-bound projects. Government Polytechnic, Kolhapur got accredited by NBA during his tenure as principal. Pioneer in designing G-Scheme curriculum for MSBTE Mumbai. Developed online monitoring system of institutes for MSBTE Mumbai and is still in practice for designing performance. Organized various types of training workshops, conferences for teachers and students in MSBTE Mumbai. Enhanced industry relation and involvement by industry at every stage of service. He has written book on valuation. He attended various national international conferences. He presented papers in national conferences. He organized training programs for teachers and staff at institute level. He visited many countries like USA, Australia, Singapore, Indonesia, Thailand, and UAE. Professor Vaidya is Executive Council member of ISTE since 2012. and he has served as Executive Secretary of IST New Delhi for more than 8 years. During his tenure, he has adopted various measures to reduce expenses. He activated various programs and activities for the betterment of technical education. May I now invite Professor Vijay D. Vaidya sir to deliver the valedictory address. Please, sir.
Yeah, Shireen, just before Professor Vaidya starts, probably I would like to talk about the great partnership that BNY and ISTE have enjoyed over the last many years. I think 10 years, probably 2016.
18, yeah.
Yeah, and so 8 years, 8, 9 years, and it's a great partnership, and all of our efforts have gone into upskilling faculty around India, across India. And thank you, Dr. Vijay sir, for all the opportunity, and thank you so much. So thank you,
Thank
sir.
you,
I just
madam.
wanted to take this opportunity to thank you. Yeah.
Thank you. So, thank you, Shirin, madam, for my introduction.
Thank you, sir.
So, good afternoon to everyone, all dignitaries present for the program, and my dear participants. First of all, I think it is my duty to say gratitude to BNY for giving us the funds for last many years, and with those funds only we were able to conduct different types of faculty development programs. And I'm proud to say that the Vidya madam is a key person for giving us the funds. The way in which she helped us for development of different faculties, it's really tremendous. And without her cooperation, I can say that it was not possible to achieve the great partnership with BNY. So I appreciate Vidya madam and the cooperation and support she is rendering. Now, if you consider this program also, this program is also actually previously we were conducting training programs for in different areas, that is AIML, cyber security or something like that for the faculties. But we came out with this different proposal, and within a short time, Dr. Vidya madam appreciated it and said, okay, sir, if you feel it is best, we'll go for that. And that is the result that we are getting these programs. So I am very much thankful to BNY and particularly Vidya madam for giving us this support. Now, basically, I am as per introduction also you must have realized I am not from a civil branch. I am from civil branch, so I don't have any in-depth knowledge about IT and computer and all. So even whatever the topic you have selected, that is going beyond my head, because the thing that are the new things, and that basically since I am not having basic knowledge about it. But one thing I'll tell you, with my experience, whatever experience I am having more than 40 years, I can say something about the technical education, about the need of the faculty and the things which we should do. Now, if you consider in I think around 1980 or something like that, that time there was a era of computer. Just computer was just introduced in India, and that time there was a feeling that computer will come and it will take our jobs and jobs will go and all. Means there will be great loss in jobs. So there it will be very difficult for the people to get the jobs. And that time there were agitations from bank employees and other people also. For they were saying that please don't introduce computer in the banking system or something like that, because it will take out the jobs. But what is the result? Now, if you see that without computer, the bank cannot work, and with the bank, with the help of computer, they have developed like anything. Means, suppose if the computer wouldn't have come, do you think that banks would have developed like this? It was not possible, because with the computer only now, by sitting in a room or sitting in anywhere, we just do the transactions and get approved. But previously, we had to go to the bank, we had to stand in a queue, and all those things were there. So that time, the fear was there, but that was overcome. And afterwards, people realized that it is a great thing that computer should be there. Then, if you consider 2000 year, there was a Y2K problem, where in which it was said that after 2000 that you have to change the date and all. So that time there were plenty of jobs, but after that jobs will be reduced. But if you consider the result, the jobs are still there. The number of jobs also increased. Means even the whatever fear people have, that was that of no use, or that was not correct, and a lot of jobs again came. Now, if you consider this, today it is the era of AI, artificial intelligence, and now the people are saying that due to AI, the people will lose jobs and all, and now there is still that companies are reducing they are removing their employees due to this AI and all. Definitely that is there, but one thing is there, new kind of jobs, new jobs are going to come. Only thing is that the person should know what skill I should achieve and what I should do so to get the jobs. Now, if you consider why I'm introducing all these things is that it is related with the basic theme or basic objective of these types of programs. Now, if you consider the, do you feel that whatever we are teaching in the classroom, is there anything obsolete in that? A lot of things are obsolete. Sometimes many things we are teaching, but we don't know whether they are essential or not. But if you have interaction with the industry people or the people who are working in the field, they will tell you something different. They'll say that we need this, we are working on this, we are doing this and all. But if you say we are not teaching the students. Now our main aim is that when we are working as a teacher, we should see that the whatever students we are teaching, they should be developed properly and they should be industry ready. Means industry should be ready to accept them. Now, if you consider the employability of the students, you'll find that different surveys have indicated that the employability of the students is very low. What is the reason behind that? We are doing our all efforts. We as a teacher, we are doing all our efforts to make them to teach them everything. We are trying our best to get out of best from them. But even after that, it is said that the number of students who are employable is quite less. Now, if that is the fact, we have to do something in that regard. So here, the basic objective of this program is to give information about the new trends and technologies that are coming that are coming in the industry, and what students should do or what students should uh, learn to get the jobs in future. Now, if you consider this aspect, you will find that we have strictly said that the persons from IITs, NITs, and industries, they should be invited for this program. And I think that RMK group is one of the renowned group in India. So definitely they must have conducted the means, even I have seen their pamphlet also. So they have done their best to get the best from the industry as well as from the academia. So I feel that the participants are really lucky to have such a galaxy of experts for this program. And definitely what they have told you or what they have been discussing, that must be of tremendous use for you. Even in the, I think that there you may have some objection about the number of participants. We have said that maximum 50. So that number was decided during our discussion with BNY people. And what it was said that, see, if the participants will be in more number, there will not be any good interaction with the faculty. If the participants are less in number, definitely the person conducting session can have a good interaction, and people also can have good interaction, then they can get it in a better way. And that was the concept behind that. So we thought that experts should be invited, and at the same time limited participation should be there, so the outcome should be good. So I think after this, when you are taking the feedback, we'll know about the output, but definitely I am sure that the output will be very good. Now when you have interacted with these people, our intention is that once you have interaction, in future also you try to make interaction with these experts. So in case of your projects or some, you can call them for as an expert in for experts lectures in your institute or some other activities and all. Means indirectly, what I'm suggesting is that try to enhance this activity and try to have more interaction with these people with your institute, and that definitely will help you. Another thing is that during this discussion, you must have realized that what are the new trends, what are the things that are going to come, and I feel that now you will be in position to guide the student. So which sort of training programs or this various sessions or various things are available in the market, what he should do, what sort of training he should do so that he can get a good job and he can survive in a better way. One thing I'll tell you, when I was working as a principal, uh, I was proud to say that our institute was having more than 95% of employability. So in our governing council meeting, I presented that data, sir, we are having good employability and our 95% students have been employed. Then one of the expert who was from industry, he stopped me and he said, sir, no doubt your performance is good. I don't have any objection about it, but I am not happy with this performance. So I was having in the mind that he will say that, okay, now instead of 95, you go for 100%. Then I said, sir, you can explain your point. So what you expect from us? He said that I am not interested in 95%. I am interested that the students who have been employed in industry, I want to know the names of the industry, their reputation. If your students are employed in a highly reputed industry, then you can say that our institute is having good employability potential. Just employing the students in small organizations or here and there and all, and saying that we have employed 100% achievement, that is of no use. Means that cannot give you credit. If you want to give me, if you want to show your performance, you can show it by saying that so many students have been employed in such and such a big company or reputed organizations and all, and then it will show that your institute is really progressing. So that way, and that is in my mind. So whenever we say that something, you have to see the top benchmark. Just saying that we have achieved 100% or something like that, it is of no use. We have to see the what will be the highest benchmark and how we can achieve it. Then you can do it. And that is the purpose that I think that whatever with this knowledge, try to ensure that the student should be made ready to industry. And particularly, you will find that if you consider a group of students, you will find all types of students. Mean there will be some intelligent students who can do anything. There may be some hardworking students, then some sincere students, some students those who are not interested, and all sort of students will be there. But you have to identify the students and you have to guide them properly. If you find the intellectual students or who are having innovative concepts in their mind, try to encourage them, try to have interaction with these industry experts so that the projects which they are doing, that can come out as a good project, and even that may be useful for the society. You can go for patenting for that also. And if you give the direction to the student, definitely that is going to help. And then I will say one Sanskrit sloka, that is Amantram Aksharam Nasti. Amantram Aksharam Nasti means you will find not a single letter which doesn't have mantra power. Amantram Aksharam Nasti. Nasti Moolam Anaushadhim means you will not find any root of a plant which doesn't have medicinal power. Means every root has some sort of other medicinal power. That root is having medicinal power. Mantram aksharam nasti, nasti moolam anusharam. Ayogyaha purusho nasti means you will not find single person in this universe who doesn't have any capacity. Means every person must have, God has given some different capacity to every person. Only thing is that yojakas tatra durlabha means there is a deficiency of planners, yojak. And I think you are doing the rule of yojak. Means the all students are there. So you have to find the potential in them and you have to guide them and so that they will become successful. Not only successful, they will help our society to develop the society. So that is the thing. With this, I'm very happy to have a opportunity to come in this program, and particularly I am thankful to Shirin Banu and her all uh, faculty members and those who are involved in this training program. I know that they have taken tremendous effort because without efforts, you cannot arrange this type of program in a successful way. Because to get the experts, to get the participants, coordinate everything. So I think for last 15 days or more than that, you are totally involved in this, you and your team. So once again, on behalf of IST and particularly BNY also, we appreciate you for your efforts and we wish you to come again because BNY is having RMK is having very good relation with IST and they are involved in different activities also. So with this, we can come again with different activities and be part of IST activities. And at the same time, I appeal to all participants that if you are not the member of IST, please be the faculty member, take the faculty membership of this, and you will have opportunity to interact or to work with IST for different activities. And one thing, together only we can develop something for the betterment of technician education. Thank you.
Thank you so much, sir. Thanks for your encouraging talk with the faculty members. We as a faculty team, we will for sure follow the methodologies what you have mentioned here. And we are very proud to have you here as a
Madam,
chief.
1 minute. Madam, 1 minute. Sir,
Yes,
sorry,
sir.
sir.
Good
I
evening,
have
sir.
not taken in Junaid, sir. He is
Good
our
afternoon,
IC
sir.
member, council
Thank you,
member,
sir. Thanks,
and one of
thanks
our
for
good friends.
accepting our
Yeah,
invitation.
sir, really, yeah. It was very nicely organized by your organization.
Excellent,
So
sir. Excellent.
I appreciate you and particularly team of Shirin Banu for
Correct.
conducting this program in a most appropriate manner. Thank you, sir.
Thank you, sir. Thank you. We are very fortunate to have you as a
Yes,
chief
sir.
guest for our valedictory function.
Yes, sir.
Thank you very much, sir. So thanks to all the participants, registered participants who have attended this FDP organized by IT department of our RMK Engineering College, sponsored by ISTE and BNY. On behalf of our respected chairman, sir, all the members of the management, faculty members, students, and my own behalf, our heartfelt thanks to all the participants and also guests, chief guests, and resource persons. And very sincere thanks to all the faculty members of IT department and the HOD, Dr. Sirin Banu Madam, for making tireless efforts to organize this event in a successful manner. Thank you. Thank you. Sorry for
Yes,
joining late. I held up in a meeting.
No,
I was
no,
held up in a
yeah.
meeting.
I do understand, sir. Yeah.
Thank you.
Yeah,
Thank you, sir. Dr. Vidya ma'am is also here, sir.
Madam, thank you, madam. Thank you, madam.
Thank you, sir.
Okay, thank you. Hope you are fine, madam.
Yes, sir.
Yeah, we are very fortunate
Very
to have
fine.
such an eminent personalities during inaugural and also valedictory function from ISTE and BNY Milan, madam. So thank you once again, madam. Thank you.
Thank you. Thank you, sir.
Thank you, sir.
Great, great program, I would say, sir.
Thank you, sir. Kanika, you can proceed.
Thank you.
Yes, ma'am. Thank you, Professor Vijay D. Vaidya, sir, for your inspiring and insightful address. We sincerely appreciate your presence and guidance in making this program very successful. Thank you, sir. So now, as we come to the successful completion of this enriching FDP program, we would like to invite the participant to share your valuable feedback and learning experience from the session. I would like to request the first Dr. K.L. Shinmuganathan, Professor and Dean, Department of IT, Rajalakshmi Engineering College, to share your feedback and learning experience about this FDP program, sir.
Thank you, madam. May I audible, madam?
Yes, sir, you are audible.
Yeah. First of all, I congratulate RMK Engineering College. As an old faculty of RMK Engineering College, I worked with Sherin Banu madam and Dr. Muhammad Junaid. So I have a lot of experience in this FDP. I congratulate Dr. Sherin Banu madam as a HOD of Information Technology. And IST, Indian Society for Technical Education, I am a life member. And Bank of New York Mellon, they are giving a full support to ISTE to conduct all these FDPs. So the way of organizing this program, I congratulate once again HOD IT madam. You selected a very recent topic. When I am speaking with my Rajalakshmi Engineering College faculty members, what is federated learning? They don't know about federated learning. They know about only supervised, unsupervised, and also reinforced learning. The next level, they are not into. So you show a pathway to have this federated learning and also quantum computing. Our engineering college, we have our group of institutions, right? We have a quantum computing lab. We are studying it. So this is the right time. You give a pathway to learn more. And this institution, RMK Engineering College, they show a pathway to learn more about quantum computing, federated learning, everything, right? And also I thank Vidya Shankar, BMY from Anna University. Thank you so much, madam. And also Vijay Vaidya, ISTE. Thank you so much, sir. And I have been associated with all these FDPs. I am learning because I am the age of 57. I don't know what is quantum computing, what is federated learning, even though I am a computer science member. But every teacher should learn the latest technology. This FDP surely helpful for all the faculty members to know about the latest technology. Thank you so much, madam. Thank you. Thank you.
Thank you, sir. Thank you so much.
Thank you.
Thank you so much, sir, for your valuable suggestion. Next, I would like to call Dr. B. Hemalata, Assistant Professor, Department of ECE, Bharat Institute of Higher Education and Research. Please share your feedback and learning experience through this FDP manner.
Thank you, ma'am. Good afternoon, all. I express my sincere appreciation for the faculty development program organized by Department of Information Technology of RMK Engineering College. I really thank Manu ma'am for organizing such an excellent featured topic for conducting this FDP program. And I would like to extend my sincere thanks to the organizing committee for their hard work in putting together such a high quality program. The coordination was seamless and the learning experience was very valuable. The program was exceptionally well organized and academically enriching. I would like to highlight the following points regarding this FTP. The focus on quantum assisted federated learning was perfect for today's fast changing world of smart technology, and the resource persons demonstrated profound knowledge bridging the gap between the theoretical quantum mechanics and practical machine learning applications. The session were structured logically and providing a clear roadmap from the fundamental security challenges to advanced quantum solutions. Thank you for providing such a valuable platform for professional development and academic growth. A big thank you to the organizing team on behalf of all the attendees. We truly enjoyed the program and appreciate the excellent coordination and the high quality of the session. Once again, I have to thank Banu ma'am and Nitya ma'am and Vaidi sir for giving support for organizing such a wonderful program. In future, we are expecting more programs like this. Thank you very much. Thank you all.
Thank you, madam. Thank you so much.
Thank you, madam. I would like to call upon Ms. A. Kalyani, Assistant Professor, Department of AAML, Malla Reddy University, Hyderabad. Please join, madam.
Kanika, madam is having some technical issue, it seems, ma'am.
Do anyone have a general feedback to share about this FDP? You're always welcome.
Kanika, you can proceed with
Yes, ma'am, I will proceed. Okay. So thank you to all the participants for your enthusiastic involvement and active participation throughout the 6-day program. I request all the participants to kindly turn on your cameras as we are going to take a screenshot of the session. Kindly, please switch on your camera. So I request all the participants to kindly turn on your cameras. We just take a screenshot of the session.
I think you need to change the focus. Not sure.
Ma'am is taking the screenshot, ma'am.
Yes, ma'am. I'm taking it in a grid view. Yeah. Thank you, sir, madam. Thank you so much.
Yes,
Have taken it. You can proceed. Yeah.
Yes, ma'am. Thank you, participants. You can turn off your camera if you want. So finally, moving on to the conclusion segment of the today's function, I request Dr. K. Saravanan, Professor, Department of Information Technology, RMK Engineering College, to deliver the vote of thanks.
Good afternoon to everyone present here. It gives me immense pleasure to propose the vote of thanks for this valedictory function of the ISTE-BNY Knowledge Enhancement Program, 6-day FDP program on Quantum Assisted Federated Learning for Secure Distributed Intelligence, organized by the Department of Information Technology, RMK Engineering College, from 6th to 12th May 2026. First and foremost, I express our heartfelt gratitude to the management of RMK Engineering College for continuously motivating and supporting us in organizing academic programs that enrich knowledge, innovation, and research culture. I extend my sincere thanks to our esteemed guest of honor, Dr. Vidya Durai, Director BNY, for gracing this occasion and for the valuable support extended towards this knowledge enhancement initiative. I convey my profound gratitude to Professor Vijaya D. Vaidya, Coordinator IST BNY, for delivering the valedictory address and for his continuous encouragement towards faculty empowerment and technical education. My sincere thanks to our beloved principal, Dr. K. Mohammed Junaid, for his motivation and providing all the necessary support for the successful conduct of this FDP. I would like to express my sincere thanks to Dr. K.K. Sivanana Prabhu, Dean CDC, for his constant encouragement and support towards the successful organization of this program. I also extend my gratitude to Dr. M. Sedin Bono, Head of the Information Technology, for welcome address and introducing the dignitaries for her valuable guidance throughout the program. A special note of thanks to all the eminent resource persons who shared their expertise and insights during these 6 days. Their sessions on quantum computing, federated learning, blockchain, security, and distributed intelligence have greatly benefited all the participants. I wholeheartedly thank all the faculty participants from various institutions across the country for their active involvement, enthusiastic participants, and fruitful interaction throughout the FDP. I would also like to appreciate the organizing committee members, faculty coordinators, technical support team, and administrative staff whose dedicated efforts ensured the smooth and successful execution of this program. Finally, I thank everyone gathered here today for making this valedictory function meaningful and memorable. Once again, thank you all. Have a great day ahead. Thank you.
Thank you, sir. Thank you for your vote of thanks. The final ISTE feedback form from the ISTE and online test link will be shared to your registered mail ID. So participants are requested to complete both the feedback form and the online test, as they are very important and mandatory. Kindly ensure that both are completed before 8 p.m. today. So thank you once again, everyone, and wishing you all the very best. Thank you.
Thank you, everyone. Thank you all. As mentioned by Ms. Kanika, I request all the participants to complete the online test. You will be having 50 MCQ questions. You have to complete that test by today before 8 p.m. And that is mandatory to receive the certificate from ISTE-BNY. You have to secure 60% and above for receiving the certificate. I hope all the participants will complete the online assessment before 8 p.m. today. Thank you. Thank you so much.
Thank you.
Thank you all.
Thank you all.
Thank you. Thank you, sir. Vidya ma'am, thank you. Vijay sir, thank you.
So Vijay sir, thank you. Vidya ma'am, thank you.
Thank you. Thank you so much.
Thank you, ma'am.
Yeah.
Vijay sir, thank you so much, sir. You're on mute, sir.
Thank you, madam. It was really nicely organized program.
Thank you for the
Great wishes to
wonderful
you and your
opportunity,
team.
sir.
Yeah.
Thank
Really
Thank you,
great.
Professor. Thank you.
Thank you.
Thank
So
you.
I also, Anay, one thing I have forgotten to mention name of Shravanam also, because he was also in constant touch with me
Yeah.
for different things.
Yeah. Yeah.
Yeah.
Yes.
Thank you, Professor. Thank you.
So,
Thank you, sir.